Hello friends, do you wish to score a perfect A star in your 9709 course? Then let me tell you this. You'll need two things to achieve this dream of yours. First is your dedication, and the second one is proper guidance. Hello everyone, I welcome you all. My name is Pankaj, your very own maths mentor for Cambridge Mathematics, and together we are going to achieve this dream of yours to score a perfect A star in 9709 mathematics course. So students, in this session, we're going to start solving the AL mechanics paper from the year 2021, the October-November series. The question paper code is 9709/41. So without much ado, let's begin the day. So students, let me quickly go ahead and share my screen. As you can see, we are going to start solving the Cambridge International AS and A-level question paper for mathematics, paper 4 mechanics, the October-November series from the year 2021, and the QP code you can see is 9709/41. Now you need to know that this question paper is for 50 marks and the time allotted to complete this paper is 1 hour and 15 minutes. I hope you are all pretty aware of that. Now, students, there are a few things that you always need to make a note of. Keep these things in mind before you start solving your question paper. Please go to the instructions. In the instructions, you can see this one, which says that you should show all the necessary working very clearly. Because if working is not given and the answers are directly given from the calculator without any kind of working, then you might lose on getting full marks for that particular question. So no unsupported answers should be provided. You please make sure that you give all the working. The second thing that you need to take care of is give non-exact numerical answers correct up to 3 significant figures and 1 decimal place for angles which are written in degrees. So if the angle is written in degrees, then 1 decimal place. If it is written in radians, then you give 3 significant figures. If the level of accuracy is specified in the question, follow that. And the last one that you need to take care of is the value of g. So the value of g should be taken as 10 meter per second square. The acceleration due to gravity needs to be taken as 10 meter per second square. So these 2-3 things that should be always kept in mind before you start the question paper. So students, let's proceed with the very first question. So you can see in the very first question, what do you have? So it says that a bus moves from rest with constant acceleration for 12 seconds. So there is constant acceleration for 12 seconds. So constant acceleration, that means uniform acceleration. If there is uniform acceleration, then the velocity will increase linearly. You want to remember this from the motion curves. We have learned this concept. Students, if a body or a particle is moving with constant, or we say uniform acceleration, then its velocity will be increasing linearly. Okay. Now, for the first 12 seconds, there is uniform acceleration. Then it moves with constant speed. So when you say constant speed, that means acceleration is 0, right? Constant speed. So speed is maintained constant. That means the acceleration is going to be 0. And then what happens is it deaccelerates uniformly. So again, there is deacceleration, and that is uniform, isn't it? So constant deacceleration or uniform deacceleration, and the particle comes to rest. The body comes to rest in next 6 seconds. So you want to read the question very carefully. Unlike mathematics, in mechanics, lot of information is hidden into every single line, every single word that you read. So one more thing is given in the question. The total distance traveled is 585 meters. You want to find the constant speed of the bus. The question is for 2 marks. Let's see how to proceed for the solution. So the question says that the bus is moving from rest. So when I say from rest, that means its initial velocity, the velocity with which the bus is going to start is 0 meter per second. So I can write here from rest. So initial velocity is 0 meters per second, and there is a constant acceleration for 12 seconds. So as I said, the velocity is going to increase linearly. Okay, so let me draw the velocity time diagram. I'm going to draw the VT diagram, students. Let me draw the VT diagram. So I make the vertical line. That's a vertical line. That's a y-axis on which velocity is going to come, meter per second. And let me draw the horizontal line as well. So I'll make this line straight. Okay. And now I take the x-axis on which t will be represented, and it is in seconds, right? This is the origin O. Now it is told to us that the bus is moving from rest, so of course it will start from this point here, isn't it? It will start from the origin. It will start at t equal to 0 with initial velocity as 0. Then for the first 12 seconds it moves with constant acceleration, so uniform acceleration. Velocity will be linearly increasing. Okay, so it will increase like this for the first 12 seconds. Let's say this is 12 seconds. I draw a vertical line as well here to signify that this is 12 seconds. That's a vertical line that has been drawn. So this is 12 seconds. Okay, now I can see that in 12 seconds, the particle is going to attain some velocity, right? I do not know what that velocity is. Let's say that velocity is v. Okay, I'm going to consider that the particle at the end of 12 seconds has attained a velocity of v meter per second. After this, what has happened? For the next 30 seconds, the body is moving at a constant speed. So whatever speed you have achieved at the end of 12 seconds, the body will keep on moving with the exact same velocity, exact same speed for the next 30 seconds. So that's 12 plus 30. It's going to be 42 seconds. So for the next 30 seconds, velocity is going to be constant, and it is going to be again v meter per second. So again, I'll draw a vertical line, or maybe I can just copy this line. Let's copy this line and place it over here. So this is where t is equal to how much? So this is 42 seconds. Okay, the duration is 30 seconds, but this is 42 seconds. So I can write over here the duration is 30 seconds. Now, what has happened for the next 6 seconds? The particle has come to rest. So in the next 6 seconds, the particle has come to rest. Try and draw appropriate diagrams that will help you to get the solution very quickly. So this is another 6 seconds. So that's 48 plus 6. That should give you 48. So the duration over here is just 6 seconds. So that's 6 seconds. Okay. Now you can see that when the acceleration was uniform, velocity is always linear. Okay, so this one concept of velocity time diagram, or I can say the motion curves, must be remembered. If you're not aware of this, make a note of this. If the acceleration is constant, then the velocity will be linear. If it is accelerating, it will be linearly increasing. If it is deaccelerating, the velocity will be decreasing. Okay, now the question now says find the constant speed of the bus. So I need to find v. Now students, you want to remember this concept very well. So there are 3 different motion curves that you have learned. One is the AT diagram, acceleration versus time, isn't it? Then you have the VT diagram, VT curve, and then you have the XT curve. So VT curve is the velocity time, XT curve is the displacement time, or I can say the distance time diagram. So always remember, if you have the AT curve, if you know the AT curve, then you can get the VT curve. You can get the VT curve by getting the area under the curve, and area under the curve is integration. So if you do integration to the AT curve, you can get the VT curve. And if you have the VT curve and you need the XT curve, again, you want to do the integration. So basically you are finding the area under the curve, finding area under the curve. So you want to remember this chain. So AT, VT, and XT. So from AT to VT, if you want to go, find the area under the curve. That means you do integration. If you have VT curve and from VT to XT, if you want to go, then again you want to integrate. You want to integrate the curve that is given to you. That means you want to basically get the area under the curve. Okay. Similarly, if you are given the XT curve and you want to get the VT curve, you want to differentiate. You want to differentiate. Okay, so differentiate the XT curve, find the slope, you get the VT curve. If you are given the VT curve and you want to get the AT curve, again you want to differentiate. So this sequence must always be remembered. So from AT to VT, VT to XT, do integration. From XT to VT, VT to AT, you do differentiation. So in our case, what is needed? Find the constant speed of the bus. I need the velocity. And are you given the total distance that has been traveled by the bus? It is 585 meters, if you can see, right? So I know the distance, isn't it? So that means I am given the XT curve. So I'm given the value from the XT curve. So to get the XT curve, what I need to do, if I have the VT curve, I want the XT curve, I do integration, or I very simply say, I will find the area under the curve. So can you observe here? If you take this region, I'm going to shade the region for you. Look at this region over here. This region that you can see, this is the area under which part? Which part of the curve? So this is the area under, I can name it as, say, O, and this point I can call it as A. This point I can call it as B, and this point I will call it as C. So you can observe this shaded region is the area under the curve OA, isn't it? So this is the area under the curve OA. Under the curve OA. So can you find the area under the curve? So area under the curve is going to be the displacement of the particle, students. So remember this very carefully. The area under the curve, which curve? VT curve. So area under the VT curve will give you the displacement. And if you find the derivative of this curve, it will give you the acceleration. Okay. So this is one part. Okay. So from 0 to 12 seconds, so that's 12. So this is a triangle and you can very easily get the area, right? Further, look at part AB. So part AB, you can observe for part AB, this is the area under the curve, isn't it? This is the area under the curve. I'm going to shade the entire area very quickly. Okay, so that's the area under the curve for part AB. So what kind of area can you see over here? What is this area? This area is nothing but what? It's a rectangle, isn't it, students? And you very well know how to find the area of rectangle, isn't it? So this is the area under which curve? Area under curve AB. So that's area under curve AB. And lastly, I'm going to take the area under the curve BC. So I'm going to shade this region over here. So that's the area under which curve? That's the area under the curve BC. And this area is what? Again, it's a triangle, isn't it? So this is area under the curve BC. Area under curve BC. So I can say area under the entire VT curve is equal to the displacement of the particle. Now in the exam, you need not do all this stuff, students. Okay, there is no need to do all this stuff. This is an explanation that I'm giving to you all to understand how the question needs to be solved. What's the concept behind the question. That is what I am trying to do over here. Okay, so you need not give all this information in your solution. Just you want to understand how the question has to be solved, and then you can frame your own solution. So area under the entire VT curve is going to be equal to the displacement of the particle. So area under the curve OA, that's a triangle. So this area is going to be how much? It's going to be half base into height, right? So I can write over here 1 upon 2. What's the length of the base? So base is 12, right? This is 12, base is 12. And what's the height? The height is V, isn't it? V is your height. V is your height for the triangle under the curve OA. So that's 12 into V. Then plus area under the curve AB. So that's a rectangle. Its length is going to be L into B, length into breadth, isn't it? So length is 30, right? So it's not 42, it's 30 into the breadth or width is V. So that's 30 times of V, and then plus the area of the triangle, which is under the curve BC. So again, half base into height, half base into height. So this time what's the base? Base is 6 and the height is V, right? The height is V. So it's 1 upon 2, base is 6 and the height is V. And this total value should become equal to the total displacement of the particle. So the displacement of the particle is 585 meters, right? So it's going to be equal to 585. So now I'm going to simplify all this. So I get 1 upon 2 multiplied with 12. That's going to be 6V plus 30V plus 3V is equal to 585 meters. So that's 6 plus 30, 36 plus 3, 39V. 39V is equal to 585. So V comes out to be 585 divided by 39. So I quickly take the calculator. So my answer is going to be 585 divided by 39. It's 15. And students, you have found the velocity. So it's going to be 15 meter per second. So that's 15 meter per second. So what's the constant velocity that you have got? The constant velocity or the constant speed of the bus is 15 meter per second. So that's your answer. So I'm going to just shade that answer, 15 meter per second. Okay, now the next question is to find the magnitude of deceleration. So where is the deceleration happening? Students, you know that this is the place where acceleration is happening, right? This is acceleration, isn't it? Velocity is increasing, and this is the place where there is deceleration, or I can say deceleration. So what do you want to find? You want to find the magnitude. You don't want to find the deceleration. You want to find the magnitude of the deceleration, not just deceleration, right? So let's find a deceleration first of all. So as I said, how do you get the acceleration curve? So students, AT curve, VT curve, XT curve. So VT to XT, find area under the curve. You get XT curve. From VT, if you want AT, what you need to do? You want to differentiate. Now differentiate the curve, or I should say, now differentiation is nothing but what? It's a slope, right? It's the slope of the tangent to the curve. Here the curve is simply a line BC. You find the slope of this line BC. Slope of the line BC would become what? Slope of the line BC will become the acceleration for that 6 seconds. It's uniform acceleration, right? If it's uniform acceleration from B to C, the acceleration, the particle for where it is traveling for that last 6 seconds, the acceleration is going to be constant. Okay, acceleration is going to be constant. And how do I get this acceleration? Just find the slope of line BC. Just simply get the slope of line BC. So for that, what I'm going to do here is I'm going to write the coordinates of point B and point C. Write the coordinates. Getting, students? So for point B, what are the coordinates? Can you look at the diagram and tell me what the coordinates are going to be? So the coordinates of point B is going to be 42. The X coordinate is 42, right? 42. And the Y coordinate is V. And how much is V that you have? V is 15, right? So it's 42, 15. Can you also tell me the coordinates of point C? So for point C, the coordinates are going to be 48, 0. So I have the coordinates of points B and C. I'm going to find the slope of BC. So I can now say acceleration or deceleration, AT curve. Acceleration is going to be slope of VT curve, that is slope of BC, that's y2 minus y1 divided by x2 minus x1. No need to write all this stuff. You just know how to find the slope of BC, get the coordinates of B and C. Of course, you need to show the coordinates of B and C into the diagram. So I can do y2 minus y1, so that's 0 minus 15, 0 minus 15 divided by, that was y2 minus y1 divided by x2 minus x1, so 48 minus 42. So I write here 48 minus 42, so that gives me minus 15 divided by 6. So I'll be getting minus 15 divided by 6 should give me minus 2.5. Okay, so that's minus 2.5 meter per second square. That's the deceleration. But what you want to find, you want to find the magnitude. Students, look at the question. Question says only find the magnitude. Okay, so marks will get deducted if you do not write the magnitude. Acceleration is absolutely correct. Okay, but then you want to just write the magnitude. So therefore, magnitude of deceleration is how much? 2.5 meter per second square. That's your answer. Okay, so that has fetched you another 1 mark. So can you understand, you did not write all the things that I've written on the screen for 1 mark. You just want to know how to find the deceleration, just find the slope. That's all that you need to do. Okay, so that was all about the first question. Now we are going to proceed ahead with the second question, students. So in the second question, students, what do we have? We have two small smooth spheres A and B of equal radii and of masses km, kg and mkg respectively. Now, can you see two small smooth spheres? When I say smooth, when this word smooth comes, the examiner is trying to tell you that there is no friction. Okay, you want to understand this. Smooth means there is no friction between the two bodies. So two small smooth spheres A and B, and they are of equal radii. So when I say equal radii, that means the two spheres are both identical. Okay, so they are of the same radius, they are of the same size, and the masses is given to us as km and mkg respectively. So mass of A is km and mass of B is m. Also it is told to us that k is greater than 1. So it's a clear indication, if k is greater than 1, then mass of A is definitely more than the mass of B. A is heavier than B. So you can imagine a pool table. Okay, so I have never played that game. Okay, I don't know about the game of billiards or the pool table, but my assumption is the ball with which we are going to strike might be slightly heavier than the other balls. Okay, you might correct me if I'm wrong. You can go to the comment section and put this information. That will give a added knowledge to me as well. So I'm assuming that the ball with which we are going to strike all the other balls might be slightly heavier than the remaining ones, but they are all of identical size, right? They are all of same size, equal radius. So two small smooth spheres A and B of equal radius and masses are given to us, and they are free to move on a smooth horizontal plane. So it's like the billiards table itself, the pool table itself. Okay, now A is moving towards B with a speed of 6 meter per second, and B is moving towards A with a speed of 2 meter per second. So it's like A and B are moving towards each other. Okay, A and B are moving towards each other. A is moving faster, its speed is 6 meter per second, and B is moving towards A with a speed of 2 meter per second. Okay, now after collision, so that's going to happen, the collision is going to happen, and they coalesce and move with same speed of 4 meter per second. So they both unite with each other. They come into unity and then they move in one direction with speed of 4 meter per second. Now it's a clear indication that A is heavier. A is moving with a speed of 6 meter per second, which is more than the speed of B, and B is lighter also. Then from the concept of momentum, who is having more momentum? Students, you know momentum is given by what? Mass into velocity. A is heavier than B. A is having more velocity than B, then of course A will have greater momentum. Getting or not? And both A and B are coming closer to each other. They both collide with each other and they both move in the same direction. Whose direction? They will both move in the direction of A because A is having greater momentum. So after collision, A and B coalesce and move with speed 4 meter per second. Find the value of K. So I'm going to draw a small diagram over here. Let's first of all draw the diagram before collision. So this question is of impact and collision. Okay, so I'm going to make use of the law of conservation of momentum, which says that the total momentum should always be conserved. The initial momentum of the system and the final momentum of the system will be exactly equal. Okay, so let's draw the diagram before collision. So I'm going to draw a circle. So you want to understand that this circle is actually a sphere. Okay, so that's a sphere that I've drawn. I'm going to duplicate this. Let's duplicate it. Okay, I'll just place it here. And again, I'll duplicate this for the second diagram. Okay, in the second diagram, what I'm going to do, this is after collision. Okay, this is after collision. So there are two diagrams which I'm going to make. One is before collision and one is after collision. Okay, so there is a collision that is happening here. There is a collision which is happening. Okay, so that's collision. So this first part is before collision, and the second diagram that I'm making is after collision. Now what you want to understand over here is the direction of velocity. Students, you want to clearly indicate which direction of velocity should be considered as positive. So we will go by the convention. Anything which moves right will be taken as positive. Okay, so I'm going to take this as the positive direction of velocity. Anything which moves right is the positive direction. So this positive direction of velocity. Okay, now this is sphere A, this is sphere B. What's the mass of sphere A given to us? It's K times of M, so Km kg. So mass of A is Km and mass of B is M kg. So I'll write very quickly in the second diagram as well. So that's sphere A, that's sphere B. Mass of sphere A is Km, mass of sphere B is K. Now what's the next thing that is happening? So before collision, A and B are moving towards each other, right? A and B are both moving towards each other. So I can have the velocity of A shown like this. Okay, that's the velocity of A. VA, it is going to be how much? This is 6 meter per second, as we know, 6 meter per second. And this is where velocity of B will be shown. It is moving in the opposite direction. It is coming towards A, that's VB. And this is going to be how much? It's going to be 2 meter per second. Remember, I have written just the magnitude of the velocity. It's 2 meter per second, but it's going in the left direction. So it's going to be minus 2 meter per second. So better what I'll do is I'll just indicate that in the diagram itself. So VB is going to be minus of 2 meter per second. Now later on, what happened after collision? So after collision, both A and B are moving in the same direction. So that's direction of VA, VA1, I will say after collision, VA1. Okay, and that's how much? 4 meter per second. And VB also moves in the same direction now, in the direction of A. Okay, they are both uniting with each other. They are both uniting with each other and they both move in the same direction now. So this is VB1, which is the velocity after collision. So that's again 4 meter per second. So VA and VB both are moving in the same direction with a speed of or velocity of 4 meter per second. So this is the most important part of the question. This is what you want to always remember. So this thing that I've noted here the direction of velocity. Students, this is what you want to pay attention for. You should always mention in what direction the velocity is taken as positive. So I have taken the right direction as positive. So anything now which moves in the left direction will be taken as negative. So what's the initial momentum of the system? So I can write over here the initial momentum. Initial momentum must be equal to, so that's mass of A into velocity of A plus mass of B into velocity of B. So what's the mass of A, students? The mass of A is K times of M. So I write K M into the velocity of A, it was 6, then plus mass of B, which is M, and velocity is -2. Have you noted this? It's -2. Velocity of B is taken as -2. So I can simply say this is 6km minus 2m. I can take out the m common. I can take out the m common and simply write it as what? 6k minus 2. I'm going to call this as equation 1. Now, what's the final momentum, students? So final momentum is going to be equal to, again, mass of A into the velocity of A after collision. So that's VA1 plus mass of B into VB1. So mass of A, it was Km, velocity of A was 4, right? Moving in the right direction, taken positive. Mass of B is M and its velocity is also 4, also going in the same direction. So this time I can take out 4m common, right? I can take out 4 and m, both of them common, or you can just keep 4 inside the bracket and simplify it, okay, later on. So I'm going to keep 4 inside the bracket. So I just take out the m common. M is common because I'm going to cancel m from both the sides. I've already told you that the initial momentum and the final momentum will be conserved. That means they will be equal. So m is taken out common. You get 4k plus 4. I'm going to call this as equation number 2. So by conservation of momentum, by conservation of momentum, initial momentum is equal to final momentum. So initial momentum is equal to the final momentum. So equate equations 1 and 2. So what do I get? So m times of 6k minus 2 will become equal to, so I just utilize some space over here, m times of 6k minus 2 is equal to m times of 4k plus 4. The m and the m cancels. Okay, 6k and 4k will come together. So that's 6k minus 4k, which will give you 2k, and the minus 2 goes on the other side, becomes plus 2. So that's 4 plus 2, which is 6. So k would come out to be equal to 3. And that's my answer for k. K is how much? K has come equal to 3. So that's the part A of the question. That was question number 2A. Now let's proceed ahead with question number 2B. So in 2B, what is he asking? Find in terms of M the loss of kinetic energy due to the collision. Of course, students, whenever the bodies are going to collide, there will be some loss in the kinetic energy. So collision produces sound, right? It will also produce heat. So due to this production of heat and sound, there will be some loss in the kinetic energy. You want to find that loss, the loss in the kinetic energy. So again, loss in the kinetic energy means what? You need to find the initial kinetic energy of the system. You want to find the final kinetic energy of the system, and you want to just subtract, right? Once you get the value of k is now known to us. The only unknown left is m, but the question says that you find this value in terms of m. So I'm not worried about m now here. So I'm going to find the initial kinetic energy first and then the final kinetic energy. So let's proceed ahead. Initial kinetic energy of the system. So you all know that the kinetic energy is given by what formula? Half mv square. So there are two bodies over here, isn't it? Does not matter what velocity I'm going to take here. The formula says half mv square. So even if you put negative value of v, what's going to happen? Its square is ultimately going to become positive. So let's not worry about the signs over here. So it's like half mass of A into VA square plus half mass of B into VB square. Now I know that mass of A was K times of how much? M, and K is 3. So it's going to be 3M now. Okay, so 1 upon 2 multiplied with 3M multiplied with velocity of A. This is initial kinetic energy of the system. So it's just before collision, right? Just before collision, when the bodies are about to collide with each other. At that time, the velocity is how much for A? It was 6. So it becomes 6 square plus half mass of B. It is M multiplied with velocity of B before, just before collision was 2. So that's 2 square. So that should give me 6 square is going to be 36, right? And then divide by 2, that will give you 18 multiplied with 3, that's 54M, 54M, and plus again 2 and 2 cancels. So this 2 and 2 cancel, you are left with 2M. So that's, let's quickly confirm it, 36 multiplied with 3 and divided by 2, that's 54, that was correct, and then plus 2M, that should give me 56M. That's 56M. So that's initial kinetic energy of the system, 56M. Now let's quickly get the final kinetic energy also. Final kinetic energy of the system. This time I'm going to make use of the velocities after collision. So that's 1 upon 2 mass of A into VA1 square plus 1 upon 2 mass of B into VB1 square. So I get 1 upon 2. What's the mass of A? It was K times of M. K was 3. So that's 3M into, after collision, the velocity was 4 meter per second. So that's 4 square. And then plus half mass of B is M. And again, it is 4 square. So that's going to be 16 upon 2, right? 16 upon 2 is what? 8. 8 times of 3. So that's 24M. 24M plus 16 upon 2. So that's 8M. So I write here 8M. That gives me 32M, right, students? That is 32M. So remember, this is kinetic energy. So kinetic energy will be in joules. This is in joules. So therefore, what is the loss of kinetic energy? So loss of kinetic energy now can be written as final kinetic energy minus the initial kinetic energy. So that's going to be how much? 56 minus 32. 56M minus 32M. That should give me, so 6 minus 2, that's 4. 5 minus 3, that's 2. 24M joules. So that's my answer. Okay, 24M joules. So I have got the second part as well. So that was question number 2B, students. Okay, now we are going to proceed with question number 3. My God, there is no other question which is simpler than this. This is what? This is coplanar forces, right? Coplanar forces, and moreover, they are concurrent as well. Every single force is starting from the same point, right? Or I can say all the forces have their line of action intersecting at exactly the same point. Such a system is called as what? It is a concurrent force system, and it is coplanar. That means all the forces are lying in the same plane. Okay, so there are what, 1, 2, 3, and 4 number of forces: 20 Newton, P Newton, 24 Newton, and 36 Newton. What you need to find is the values of P, which is unknown, and theta. So it's the inclination of P with the vertical line. Inclination of P with the vertical line. Also, you are given that sine alpha is 3 upon 5. Okay, and the system is in equilibrium. Students, what do you mean by equilibrium? When you say that the system is in equilibrium, it means that sum of all the forces should become equal to what? 0, right? That means the resultant of the force system, the resultant of the force system is going to be equal to what? It is going to be equal to 0, right? So I'm going to resolve the forces. Students, let's resolve all the forces. So you know that whenever a concurrent force system is given to you, you first of all need to resolve every single force into 2 orthogonal components, the horizontal component and the vertical component, right? So resolve every single force into 2 components, the horizontal and the vertical component, and then you sum up all the horizontal components, you sum up all the vertical components, right? But now here what's going to happen? The resultant is going to be 0. So sum of all horizontal components should become equal to 0. Sum of all vertical components should also become equal to 0. Okay. So I'm going to start resolving every single force which is present over there. So I start with the very first force, which is 20 Newton. No need to resolve 20 Newton. It is directly lying along the x-axis, right? So there is no resolution of the 20 Newton force. But look at P newtons. So P newtons will get resolved. So what I'm going to do here is I'm going to just extend this P Newton a little further. Let's say this is P Newton force. Let's extend this force. Okay, I'm going to extend this force so that becomes easier for me to resolve it. Okay, so I'm going to, this was the line of action of the P Newton force. So there will be a horizontal component like this. Okay, this is the horizontal component of the force, and this is the vertical component of the force. Students, I'm very confident that you know how to resolve the forces. So I would strongly recommend you, if there is any topic, any concept that you need an explanation for, go to the comment section. Students, go to the comment section, name that topic, and I will make every effort to make a small video of explanation for that particular topic. So that's what I can do for you. So I'm going to resolve these two forces. Now you tell me, what is the inclination of this P Newton force with the horizontal? So students, I always take the inclinations of the forces with the horizontal line. Okay, so that becomes very easy for us to understand the resolution. The horizontal component is always the cos component, and the vertical component is always the sine component. Always remember this. Okay, the orthogonal components, horizontal ones, is the cos component and the vertical one is the sine component. But for that, the inclination should be always mentioned with the horizontal line. So look at P Newton force and the horizontal line. So what I'm going to do here is I'm going to also extend my x-axis. Okay, I'm going to extend x-axis over here. So I'll use a different colored pen. Okay, so students, this is my x-axis. Okay, I'm extending the x-axis. That's my x-axis. Okay, and now if I ask you the inclination of the P Newton force with the x-axis, can you see the inclination of P Newton force with the y-axis? That's theta. So you can easily say that this angle is 90 minus theta, right? The angle made by P Newton force with the horizontal line is 90 minus theta. This angle is 90 minus theta. So I can have the horizontal component of P Newton force as P cos 90 minus theta. But don't you all know that cos of 90 minus theta is sine theta? You need to have your formulas well prepared, students. If not, please make an effort to learn the formulas. Okay, so this is nothing but P sine theta. Cos of 90 minus theta is what? Sine theta. So that's P sine theta. And the vertical component is going to be what? It's going to be P sine of angle with the horizontal was 90 minus theta. So always remember, I always take the angle made by the forces with the horizontal line. Horizontal component is the cos component and the vertical component is the sine component. So that's P sine of 90 minus theta. But we are all aware that sine of 90 minus theta is cos theta. So I have got the two components of the P Newton force. Now let's quickly move on to the 24 Newton force. I'll again make use of a different colored pen. So 24 Newton force, tell me, what's the angle made by 24 Newton force with the horizontal line? So with the horizontal line, it is this angle over here, and it's going to be what? 90 minus alpha, because the angle made by 24 Newton force with the vertical line was alpha. So again, I'm going to resolve these two forces. Let's resolve these two forces, the force 24 Newton, into two components. Okay, the two orthogonal components. Right, students? So this is going to be 24. So the vertical component is always the sine component. So 24 sine of inclination with the horizontal lines. That's 90 minus alpha. So this simply comes out to be 24 cos alpha. And the other force is going to be 24 cos 90 minus alpha. But you know that cos of 90 minus alpha is going to be sine alpha. That's 24 sine alpha. I hope this is pretty clear to you, the resolution of the forces. Right, students? Now, what next force is left? So there were total 4 number of forces, the 20 Newton, the P Newton, the 24 Newton, and the last one is 36 Newton. Its inclination with the horizontal is again what? So inclination with the horizontal here is 90 minus alpha. Okay. So I'm going to resolve the 36 Newton force also into 2 components. So one of them is the horizontal component, and this is going to be how much? 36. Horizontals are always cos. Inclination with the horizontal line is 90 minus alpha. So cos of 90 minus alpha. So that gives you 36 sine alpha. And the vertical component, students, is going to be 36 sine of 90 minus alpha. That becomes 36 cos alpha. I hope the resolution part is pretty clear to all of you, right? So now it's time for us to sum them up. I know that if I take all the horizontal components and I add them, I'll get the horizontal component of the resultant force. But the resultant force is 0. The system is in equilibrium. That means the sum of all the horizontal components should become equal to 0. Sum of all the vertical components is also going to be equal to 0. Right, guys? So let's quickly move further. Since the system is in equilibrium, let's write few steps. We have plenty of space here, right? The entire page is available. So I'm going to write here, since system is in equilibrium, summation of fx must be equal to 0. That means sum of all the x components of the forces should become equal to 0. And summation of fy will also become equal to 0. Summation of all the y components of the forces is also going to be equal to 0. So summation of fx, students, let's take summation of fx. So therefore, I'll write here, consider summation of fx equal to 0. So consider every single horizontal force. Anything which moves in the right direction will be taken as what? Anything which moves in the right direction is taken as positive. Anything which moves in the left direction will be taken negative. Remember this concept very properly. Anything which goes in the right direction is taken positive, left direction is taken negative. So can you see the 20 Newton force moving in the right direction? The very first force, 20 Newton, going in the right direction. So that's positive. So that's plus 20. Okay. Then can you see the next one is P sine theta, again going in the right direction. So I write here plus P sine theta. Then you have 24 sine alpha going in the left direction. So do you have the value of sine alpha? Student, sine alpha is 3 upon 5, right? So I'm going to write here 24 sine alpha. So I'll make a note over here. Sine alpha is how much? Sine alpha is, it's given to us 3 upon 5. So that's 24 into 3 upon 5. So I'll quickly write the answer also. It's 24 into 3 divided by 5. So it's 72 upon 5. So decimal is 14.4. So I write the answer as 14.4 newtons. Okay, so that will be easier for me to write over here. So that's P sine theta. Okay, then I had 24 sine alpha going in the left direction. It is 14.4. So I write here minus 14.4. You have understood why the negative sign has come, right? Minus 14.4. Then the next one is this 36 sine alpha. Okay, again sine alpha was 3 upon 5. So this is equal to 36 into 3 upon 5. So I'll quickly get that also. 36 into 3 divided by 5. I am pretty confident, students, that you all know how to make use of the calculator, right? So if you are having any issues using the calculator, you need to know any concept about the calculator, go ahead in the comment section. Please tell your doubts. I'll make an effort to answer those doubts. So that's 21.6. again in the left direction. So I'm going to write here minus 21.6 newtons. And all this is equal to what? Sum of all this is equal to 0. So students, can you simplify this entire equation for the value of P sine theta? So I'm going to get P sine theta from here. That's equal to what? So 21.6 plus 14.4, okay, and minus 20. That gives me 16. So P sine theta has come 16. I can call this as equation 1. P sine theta is equal to 60. I'm going to call it as equation 1. Now we're going to take summation of Fy equal to 0. So let's consider summation of Fy equal to 0. So this time we'll take all the vertical components. 20 Newton force, no vertical component. So ignore that force. Go to the next one. You have P cos theta going upwards, isn't it? So P cos theta will be taken positive. So I write here P cos theta. Then the next force is 24 cos alpha, also going in the upward direction, right? So 24 cos alpha going in the upward direction will be taken positive. Now, do you have the value of sine alpha, students? Sine alpha is 3 upon 5. So can we easily get the value of cos alpha? Yes, we can. Let's quickly get it. So I know that cos alpha is going to be under root of 1 minus sine square alpha, isn't it? You all know that sine square alpha plus cos square alpha is equal to 1. So from here, I can get the value of cos alpha as 1 minus sine square alpha under root. Okay, and I'm going to consider this value of alpha since it's acute. Okay, so cos alpha will come positive. So I have square root of 1 minus sine alpha was how much? It was 3 upon 5. Its square is going to be 9 upon 25. So it's pretty obvious that when you simplify this, that's 25 minus 9. 25 minus 9 will give you 16. 16 upon 25. Square root of that is going to be 4 upon 5. So that's 4 upon 5. So I've got a value of cos alpha, and that's 4 upon 5. So I have this vertical component as 24 cos alpha. So I'm already done with the P cos theta going upwards. Then 24 cos alpha going upwards. Cos alpha is 4 upon 5. So let's quickly get this also here. That's 24 into 4 upon 5. That should give us what? So it's always easier to write the values, students. So 24 into 4 divided by 5. That's 96 upon 5, or you can say 19.2. Okay, that's 19.2 newtons. So I'm going to write here plus 19.2. Okay, and then you have what? You have one more force, the 36 Newton force. Its vertical component is going down, so it should take a negative, and it's 36 cos alpha. So let's simplify this also. It's going to be 36 into, if you recall, cos alpha was 4 upon 5. So 36 into 4 upon 5. How much it comes? 36 into 4 upon 5. That gives me 28.8. I'm going to write here 28.8. So this is going to be minus 28.8. You know why negative, right? And the sum is equal to 0. So this time only 3 forces, right, students? This time there were only 3 vertical forces that I've considered. So can I get the value of P cos theta from here? Of course I can. So I get P cos theta is equal to, transfer the remaining 2 terms on the other side. So the 28.8 becomes positive and 19.2 becomes negative. It comes out to be 48 divided by 5, or you can say 9.6. So P cos theta has come 9.6. Okay, I'm going to call this as equation number 2. So I have 2 equations, P sine theta as 16 and P cos theta as 9.6. I want to get the value of P and theta. So to get the value of P, it's very simple. I can simply do the squaring of the 2 equations and add them. Okay, so squaring and adding 1 and 2. Squaring and adding 1 and 2. So I get P square sine square theta plus P square. The left hand sides will get squared and added to each other. So will be the right hand side, 16 square plus 9.6 square. So you can easily take out the P square common. You are left with sine square theta plus cos square theta. You very well know that's 1. So you are left with P square is equal to 16 square plus 9.6 square. Okay, so 9.6 square, 16 square That's 8704 divided by 25. I just write it over here. 8704 divided by 25, and that should give us the value of P. How much? Take the square root of this value. That's 16 root of 34 upon 5, which gives me 18.659. So do you recall this is 18.659? So the question paper at the beginning gave us an instruction that if you have decimal values, okay, if you're finding some values other than the angles, you should write three significant figures. So that's 18.659. So I can write this as, therefore P is equal to 18.7 newtons. Okay, that's the value of P, 18.7 newtons. Okay, now I also need to find the value of theta. So for that, I'm going to divide equation 1 by 2. So let's divide equation 1 by 2. Equation 1 gets divided by equation 2. So I write P sine theta divided by P cos theta. So what's P sine theta, students? P sine theta was 16 and P cos theta was 9.6. So 16 upon 9.6. P and P cancel. Sine theta upon cos theta is tan theta is equal to. So let's quickly write 16 divided by 9.6. It comes out to be 5 upon 3. So tan theta is 5 upon 3. So I can easily get the value of theta. That's tan inverse of 5 upon 3. So now you are getting angle, and angle you are finding in degrees. So you should keep your calculator in degree mode, students. Tan inverse of 5 divided by 3. So that's 59.03624 and so on. So I'm going to write here 59.03624 degrees. But the instructions which were given to us tells us that if you're finding angles in degrees, you just want to maintain one decimal place. So decimal place, I have 036. So that's 04. So 59.04. Or you can just continue as 59. So therefore, theta is equal to 59 degrees. So that's your answer for theta also. So I've got the value of P and the value of theta. So that's how we have solved question number 3, right, students? So I'm pretty confident that this question is also understood by you. And it's now time for us to move on to our next question, which is question number 4. So the question says a particle of mass 12 kg is stationary on a rough plane, inclined at an angle of 25 degrees to the horizontal. A force of magnitude P Newton acting parallel to a line of greatest slope of the plane is used to prevent the particle sliding down the plane. The coefficient of friction between the plane and the particle is 0.35. Draw a sketch showing the forces acting on the particle and also find the least possible value of P. That's what the question is, students. So the question is of friction, right? It is from the topic friction. It says that there is a particle whose mass is 12 kg and this particle is stationary on a rough plane. That means the particle is not moving. Okay, particle is stationary. So this is definitely a question on friction. Okay, so sometimes the question on friction also falls into D'Alembert's principle. But then in D'Alembert's principle, the particle is in motion. Okay, here the particle is stationary. So this definitely belongs to friction and not on D'Alembert's principle. So particle of mass 12 kg is stationary on a rough plane. So the rough plane tells you that the particle will be experiencing friction. The plane is inclined at an angle of 25 degrees to the horizontal. Then there's a force of magnitude P Newton, which is acting parallel to the line of greatest slope of the plane. So there is a plane like this, and then you draw a line which is parallel to a line of greatest slope. So to this plane, the line of greatest slope will be the plane itself. Okay, and this force is used to prevent the particle from sliding down the plane. Now try to understand. There can be two different conditions that I can discuss over here. The question demands a particular condition. Okay, so I'm going to discuss both the conditions and then we will go on to discuss the condition that is given in our question. When a body is kept on an inclined plane, there are two different things that can happen. First, you can start pulling the block up the plane, pulling the block up the plane. Now to pull the block up the plane, force will be necessary. Similarly, now where is the motion? Where is the motion of the block? The block is going up the plane. You are trying to pull it up the plane. Okay, so the amount of force that is applied here is tremendously high compared to the amount of force that will be needed to just hold the block from going in the downward direction. So try to understand, block, when it is trying to go in the downward direction, so it is the impending motion is downwards. When I say impending motion, it means where the block is trying to move. So the block is trying to move in the downward direction, but what you have done, you have applied a force in such a way that it is just holding the block from moving in the downward direction. You are not pulling the block. You are just applied the force in such a way that the block is prevented from going down. You can find some kind of P over here. Likewise, if you take a block and you start pulling the block, okay, so the amount of force will be higher than the amount of force needed to hold the block. So to pull the block, amount of force is greater than the amount of force needed to hold the block. In our question, you want to hold the block. Okay, so the block is going down, but you are preventing it from going down by applying a force. This force is just holding the block. Okay, so you want to find the least possible value of P. So there can be a range of P. Okay, the amount of P that is needed to start the motion of the body in the upward direction, the amount of P that is needed to hold the body from going in the downward direction. We want to discuss the second condition over here. The body is going down, it is trying to go down, you are holding it from going down by applying a force P. That will be a least P. Okay, so first thing first, we want to draw the free body diagram. Okay, we want to draw a sketch showing all the forces which are acting on the particle. So I'm going to draw the free body diagram over here. So a particle of mass 12 kg is stationary on a rough plane which is inclined at an angle of 25 degrees to the horizontal. So the first thing that I do is I make an inclined plane. This plane is inclined at an angle of 25 degrees with the horizontal. So let's draw a horizontal line as well here. Okay, so the angle here is 25 degrees. Okay, so that's how the inclined plane is. On this plane, you are going to place a particle. So I'm going to place a block so that we are able to show all the forces very properly into the diagram. And then we'll draw, of course, the FBD as well. So the diagram that I'm drawing is definitely an FBD, but then I'll shift it to a concurrent force system. So now let's draw a block or a body, or you can call it as a particle. Let's shift it over here. That's my block. Okay, now what is the weight of the particle? It's 12 kg, right? So weight, the mass will always try to act in the downward direction. So mass is 12 kg, weight or weight force will be 12 times g, right? 12 times g, the acceleration due to gravity. And if you recall the instructions which were given on the first page, g has to be taken as 10, okay, 10 meter per second square. So always remember, the weight will always act in the vertically downward direction. Okay, so the weight always acts in the vertically downward direction. So that's the weight force. Okay, and the weight is going to be 12 into 10. Now that's 120 Newton. That's the weight force. Okay, now you are going to apply a force P in such a way which should be just holding the block. Okay, it is not pulling the block up, it is just holding the block from going down. So the block is going in the downward direction. So I'll show something called as an impending motion. Okay, this is not a force, this is the direction in which the block is going to move. So this is impending motion. So the motion of the block is in the downward direction. You are preventing its motion by applying a force which is parallel to the line of greatest slope to the plane. So it's the plane itself. So that's P newtons. Okay, that's P newtons. The next thing that you'll be finding over here is the normal reaction that is offered by the surface. Okay, the surface is supporting the block, it is supporting the particle. So there will be a normal reaction offered by the surface onto the block. So I'll be showing a perpendicular reaction like this. That's the normal reaction. Okay, that's the normal reaction. So this is the normal reaction. So the word normal means perpendicular. Normal reaction, I'll denote it as R. Now, where is the impending motion of the block? So block is trying to go in the downward direction, right? If the block is trying to go in the downward direction, the frictional force will be applied in which direction? So see, the force P is not pulling the block upwards. The block is going down. Okay, if the block is going down, friction will be always in the opposite direction. Frictional force always acts in the direction opposite to the direction of motion, the direction of impending motion. So the frictional force needs to be applied in the upward direction. Okay, so I'm going to show the frictional force over here. Let's show the frictional force. It will be acting in the upward direction, up the plane. Okay, so that's the frictional force. I'm going to denote it by F. So that's your frictional force, or we call it as a resistive force. It is denoted by F, and it is given by mu times of R, where mu is what? Mu is the coefficient of friction. So what is mu given to us? Coefficient of friction. So there is a friction between the particle or the block and the plane on which it is resting, and that coefficient of friction in the question is 0.35. It is mentioned it is 0.35. So mu is 0.35. So it's a unitless quantity. So therefore I can say F would come out to be 0.35 times of R newtons. Okay, so block has some weight. Weight will always act in the vertically downward direction. Block is resting on a plane, so there will be a normal reaction. Block is held from going down. Okay, it is prevented from going down by a force P, which is acting parallel to the inclined plane. And since the block is trying to go down, its impending motion is in the downward direction. There will be a frictional force acting in the upward direction. These are the four different forces which are acting on the body, or I can say the particle. So if I draw the FBD, so that's the FBD, we are just going to transform it into a particle. Okay, so this is the particle that we are talking about. Its weight is 12 kg. The mass is 12 kg, so the weight force becomes 120 newtons. So that is acting in the vertically downward direction. So I can show this force acting in the vertically downward direction. Okay, so that's 120 newtons. Then I can show a force P, right? That's force P, or maybe I can just copy this. Let's copy this force over here, place it over here. Okay, that's force P. Then you can copy the normal reaction, right? Place it over here. And you can also copy the frictional force. And let's place it over here. And then of course we'll show arrows to all of the forces. That's the frictional force, that's F. Then we have the P Newton force, that's P Newton force, which is holding the block. Okay, and the weight force is already shown. The green colored force is the normal reaction. Okay, going up like this. You want to show the directions very properly, students. That's a normal reaction R. Okay, and you already know the inclinations. So the frictional force F and the force P, they are both inclined by an angle of 25 degrees. Okay, so you can also show the angle. So I'm going to also first of all show the particle over here. That's the particle. Okay, and then you can also put up the horizontal line over here to indicate the inclination. Okay, so I put up the horizontal line and I'm going to indicate the inclination over here. So this is 25 degrees. This is also 25 degrees. So that will fetch you 1 mark. Of course, even if you draw the FBD with the particle with the 4 forces, that's enough. You get full 1 marks for that. Now, why did I draw the entire diagram with the body and the other forces? Because I want to start solving the second part of the question, which is for 5 marks, and it will definitely need the diagram that I've drawn. So how do we proceed, students? Now you want to clearly understand how the resolution is going to happen. So what I'm going to do here is, you can observe that there are 4 different forces which are acting on the body. Say I want to find the least possible value of P. How much P is needed to just hold the body from going in the downward direction, right? I'm going to hold this body from going in the downward direction by applying the force P. So there are total 4 forces which are acting on the body. The force P that is applied to hold the body, the weight of the body vertically downwards, the normal reaction perpendicular to the surface, and the frictional force, right? Out of 4 forces, there are 3 forces which are lying along the plane and perpendicular to the plane, along the plane and perpendicular to the plane. So what we do is we shift our coordinate axis the same way. So this is perpendicular to the plane, right? That's going to be the y-axis, and this is along the plane. That's going to be the x-axis. So anything which goes up is taken as positive. Okay, so this is positive direction of the x-axis. Up means along the plane, up along the plane, and anything which is going up perpendicular to the plane, okay, up and perpendicular to the plane, will be taken as positive for the y-axis. So you can see that the normal reaction is along the y-axis, frictional force is along the x-axis, P is along the x-axis. Only 120 Newton is a force which is not along the x or the y-axis, right? You need to resolve this 120 Newton force. So clearly understand how the coordinate system has been changed as per my convenience. Okay, out of 4 forces, there were 3 forces which were along the plane and perpendicular to the plane. So what I've done is I have taken my x and the y-axis as along and perpendicular to the plane. So 3 of the forces are directly lying along the x and the y-axis. Only 120 Newton force is not along the x or the y-axis. So I need to resolve that 120 Newton force. The 2 components of the 120 Newton force will be now along the plane and perpendicular to the plane. Students, you want to clearly understand this. The 2 components will be now along the plane and perpendicular to the plane. Okay, so I want to resolve this 120 Newton force. Let's shorten it a little bit. Okay, this is the 120 Newton force. Okay, and I'm going to resolve this 120 Newton force. I'm going to resolve. This was 12 into 10, 12 kg multiplied with g, which is 10. That gives me 120 Newton. That's the weight force. Okay, so now this weight force will get resolved into 2 components. It is going to get resolved into 2 components. One of the component is along the plane. Okay, one of the component is along the plane and it is going down. So this is also going down. Okay, and the other will be perpendicular to the plane. The other component is going to be perpendicular to the plane. These are the 2 components. Okay, now look at this. This is your 120 Newton force. This is along the plane. Okay, if you complete this angle is 25 degrees, if you remember. So this angle becomes 65 degrees. Okay, and this angle becomes again 25 degrees. So this geometry has to be well understood. I have seen people struggling with angles. Okay, so I'm going to take the angles over here. Okay, let's quickly mention the angles. So this angle, as you remember now, it was 65 degrees. And if you recall this angle, this was 25 degrees. Okay, so I have the 2 components now ready to be written. So the horizontal component is going to be always cos component with the horizontal angle, that's 65 degrees. Okay, or you can, if you want, you can take 25 degrees also, but then it will be sine. So be very careful with this. So this is going to be 120 cos of 65 degrees. Okay, and the vertical component is going to be 120 sine of 65 degrees. Students, I have made a habit of always writing the components, okay, resolving the components along the x and the y axis in such a way that the force always makes an angle with the horizontal line. Okay, so here the horizontal line was the line which was along the plane. Along the plane is my x-axis. That becomes my horizontal line. So I want to get the inclination of the force with the horizontal line, and that came 65 degrees. That's why the two components are 120 cos 65 and 120 sine 65. This could also be written as, if you want, you get the same answer. This could also be written as, if you want, a students. Otherwise, not needed. So this is 120 sine of 25 degrees, and this could be written as 120 cos of 25 degrees. But as I said, I would stick to the values which are written over here. Okay, so this is what the forces which are acting on the body. Now it's pretty simple. You want to find the value of P. P, now see, system is in equilibrium. System is not in motion, it is stationary. If the system is in equilibrium, none of the bodies are moving over here. P is holding the block from going the downward direction. So resultant must be equal to what? Resultant must be equal to 0. So system is in equilibrium. So I can write it over here. System is in equilibrium. And if the system is in equilibrium, that means I can say summation of fx and summation of fy must be equal to 0. Now, if you take summation of fx equal to 0 at the beginning, this force P is along the x-axis. You know where the x-axis is, right? So this force P is along the x-axis. So I have to get the value of P. There are a few other things which are not known to me. The normal reaction is not known to me, right? So I first of all need to get the normal reaction. So instead of starting with summation of fx, I'll start with summation of fy. It is just the convenient way of solving the question. It does not matter whether you start with summation of fx or summation of fy. Okay, so I'm going to start with summation of fy. System is in equilibrium, so summation of fy must be equal to 0. Now tilt your head like this, okay, because x is along the plane and y is perpendicular to the plane. Okay, so you want to tilt your head in such a way that you see the x and the y axis like this, x and y. And now any force which is perpendicular to the plane is along the y-axis. So anything which goes down perpendicular, take a negative, up perpendicular to the plane, take a positive. So look at the diagram. Look at the diagram. Can you identify the two forces? Can you identify the two forces which are perpendicular to the plane? So you have guessed it right, students. One of them is the normal reaction R, the green colored force going in the upward direction, and the pinkish colored force which is going in the downward direction, 120 sine of 65. These are the only two forces which are perpendicular to the plane. So they are along the y-axis. So I can write here summation of fy equal to 0. So the normal reaction R going upwards, so positive R, and minus of 120 sine of 65. 120 sine of 65 equal to 0. So I can easily find the value of R from here. So that's going to be 120 sine 65. Let's not write the decimal values at this moment. 120 sine of 65. So I'm not using the calculator to get this value. Keep it 120 sine of 65 newtons. Okay, call this as equation 1. Now you consider summation of fx equal to 0. Summation of fx equal to 0. Now take all the forces which are along the plane. Anything that goes up the plane will be taken positive. Anything which goes down the plane will be taken negative. So P is going up the plane, so taken positive, and that is what I want to find, right? Plus P. Then the frictional force, it is F is equal to 0.35 R. And now you have the value of R, right? So it is also up the plane. So I write plus 0.35 times of R, which is 120 sine of 65. So can you understand? The frictional force is in accordance with the P that is applied. It is helping P for the prevention of the block to slide in the downward direction, right, students? When you park a car along an inclined plane, the friction between the tire and the plane also helps the handbrake, isn't it, for prevention of the car to slide in the downward direction. So this is that frictional force which is helping the P to prevent the block from going downward direction. That's why they are both positive. And then what do you have? These are the two forces going in the upward direction, and then there is one more force which is now going in the downward direction and parallel to the plane. Along the plane, it is 120 cos of 65. So it's going to be minus 120 cos of 65 equal to 0. So I'm going to get the value of P, and definitely the value of P is going to come positive. Let's quickly check the answer. Let's make use of the calculator. So what do you have? So this negative 120 cos of 65 will go on the right side, become positive. So 120 cos of 65, I'll get some value, and this value is positive, and we're going to subtract 0.35 into 120 sine of 65. That gives you 12.64926 and so on. So that's 12.64926 newtons. So as we all know, we want to write either three significant figures. Okay, we want to write three significant figures, not either. We want to write three significant figures. So after 6, you can see there is 49, which actually becomes 12.65 newtons, right? And 12.65 is definitely equal to 12.7 newtons, right, students? Okay, so I have transformed it into three significant figures. Okay, so the value of P is 12.7 newtons. That means if you apply 12.7 newtons to this block, the block will be held in equilibrium. It will be prevented from going in the downward direction. This force is not enough to start the motion of the block in the upward direction. For that, the value will increase. The frictional force will change. Okay, and that's why the value of P will increase in that particular case. So so this is an extra information that I'm going to give you. I'm going to share this with you. So if the block is now going to go in the upward direction, if you want to apply P in such a way that the block needs to start its motion in the upward direction, the only thing that will change, the only thing that changes is the frictional force. Instead of the frictional force going up, now it will go down because the block is going up. If the block goes up, the frictional force will go in the downward direction. The frictional force is always in the direction opposite to the direction of motion. So only thing that is going to change is the sign of 0.35 into 120 sine 65 into your equation. So the plus will become minus, and that will get added to 120 cos 65, and that's why P will increase drastically. Got it? So I am pretty confident that this question is well understood. See, it was only only this much solution that you want to write, and you are going to get 5 marks for this. So be very presentive when you're writing solutions. The examiner should feel happy when he's checking your solutions. So that was all for this particular question. I'll just quickly shade my answer. This is the value of P. Okay, so P is equal to 12.7 newtons. So that was all about question number 4. We are going to proceed ahead with question number 5 now. So let's see what do we have in question number 5. So what's question number 5, students? A car of mass 1600 kg travels at constant speed 20 meter per second up a straight road inclined at an angle of sine inverse of 0.12 to the horizontal. Okay, so let's not worry about what sine inverse of 0.12 is given. Okay, this is an angle. Okay, so if you take sine inverse of 0.12, it will come some value. Okay, so if I go here, press the shift and the sine button, that will give me sine inverse, and press 0.12, the value is coming 6.8921. So that's the angle. That means the plane is inclined by an angle of 6.892 or approximately 7 degrees. So it's the same thing. See, I've discussed this in the previous question, that a car is standing on an inclined plane. So the car will be held in the position by using the handbrake. Along with the handbrake, there will be a friction between the tires and the road also. So that will also help the car from to be held in the stationary position. Okay, so I have this question number 5, part A, which asks me find the change in the potential energy of the car in 30 seconds. Okay, so that's for 3 marks. So we have a car whose mass is 1600 kg. It is traveling at a constant speed. So at this moment, it is traveling at a constant speed of 20 meters per second. If it is traveling at constant speed, what can you say about the acceleration? students, the acceleration is going to be 0, right? The speed is constant. There is no increase in the speed. If the speed is not increasing, if the speed is constant, that means it's a clear indication. It is clearly mentioned to us that the acceleration is 0 for this particular case. Okay, so find the change in the potential energy of the car in 30 seconds. Now, I'm pretty confident that all of you know what potential energy is, isn't it? So potential energy is nothing but the energy possessed by the body on account of its motion. Now start imagining this. You are on an inclined plane. Your car is on an inclined plane. Okay, and it was at some position, and from there, if it goes to a higher position, what will happen? The potential energy will increase as you go higher, right? Potential energy is the energy possessed by the body on account of its position. Higher the position, higher is the potential energy, right? So I'm going to draw a simple diagram over here. Let's draw a simple diagram. So this is the inclined plane, and the inclination is how much? The inclination is sine inverse of 0.12. So I'm not going to write what the value is. It was 6.8921. So let's keep sine inverse of 0.12. So let's draw a horizontal line as well to indicate the angle. Okay, so this angle is how much? This angle, I can name it as theta if you have to. Let's name it as theta. Okay, so theta is sine inverse of 0.12, right? Theta is sine inverse of 0.12. That means I can say sine theta. So sine inverse goes on the other side. Okay, it changes its position. So sine theta becomes equal to what? It becomes equal to 0.12. So this needs to be taken care of. Okay, so sine theta is 0.12. I am pretty confident that the things that I've written are visible. Okay, so sine theta is 0.12. So now I have a car at say position A. So I'm going to draw a small car over here. Let me try very quickly. No, I'm going to draw a car. No. What's happening? So I'll draw a small circle, duplicate it, keep it here, and let's draw a small car. Sometimes it can be pretty fun to draw diagrams like this. So you can draw a simple diagram also. You can just show a block. Okay, I sometimes enjoy doing such kind of stuff. Okay, so that's a car. I don't know how good I have drawn this car, but that serves my purpose. Okay, so there's a car. Let's say it is positioned at point A. So the position of the car is here. Okay, this is position of the car. This is point A. First position, position A. Now this car is moving for how much time? It is moving for 30 seconds. Okay, this car is moving for 30 seconds. So it will definitely change position. It will reach at some other position. Let's call that position as B. So what I'm going to do here is I'm going to draw another car. So let's duplicate this line and I'll show it somewhere here. Now this is the next position. Okay, I'm going to call this as position B. This is position B of the car. Okay, so I have this point over here. This is the point. So let's name the points. So I'm going to again shorten these lines a bit so that the diagram becomes more easily readable. So that's point A. Let me use a different colored pen as well. That's point A. That's point B. Okay. Now, what has happened is the car has changed its position. It has moved from point A to point B in a duration of what? In 30 seconds. So the time that has taken by the car to reach from point A to point B is 30 seconds. Got it? And what's the speed of the car? The speed of the car is 20 meter per second. So V is equal to 20 meter per second. Speed of the car is 20 meter per second. So now it can be easily understood, since it is constant speed, I have the formula speed is equal to distance upon time. We know speed is equal to distance upon time, right? So speed is how much? Speed is 20 meter per second. I don't know what the distance is between A to B. Distance is AB divided by for how much time it is moving. So from point A to point B, the car has taken 30 seconds. So that's 30 seconds. That means distance AB is how much? Distance AB is 600 meters. Now you must be wondering why this distance has been obtained. Okay, so students, what are we trying to find over here? There was a car which was at position A. It has moved to position B, right? From point A to point B. So there is a change in the height. It is moving up the plane. Can you see in the question? It says up a straight road. So the car is moving up the straight road. Okay, so if it is moving up the plane, there will be change in the height. If there is change in the height, I do not know how much that change is happening. Okay, how much the height has increased. So you want to know the vertical distance that has been covered by the particle. So if the particle was at this place, it will have some potential energy. Okay, if it goes to the higher place, it will have a different potential energy. So there's a change in the height. So the vertical distance is needed, students. So what I'm going to do here is I'm going to draw a line emerging out of A, okay, such that it is parallel. So I'll draw a better line. It is parallel to the horizontal. Okay, so this line is parallel to the horizontal. And from point B, I draw a vertical line. Let's draw a vertical line from point B. So can you see that both the lines are intersecting each other, and the triangle that is formed over here, you can see the triangle that is formed, isn't it? So this triangle that is formed over here is what kind of a triangle? Is it a right angle triangle? I'm going to name that one point of intersection that I've got here. So I'm going to name this point of intersection as, let's say, C. Okay, or not C, let's name it as some different point. Maybe I can name it as M. So look at this triangle AMB. It's a right angle triangle, and I'm interested in the length of BM. Length of BM is the vertical displacement of the particle. Can you understand? The vertical displacement of the car is the distance BM, and that's H. So BM is H. Okay, and this angle is theta, which is sine inverse of 0.12, right? Do you know length of AB? Students, have you got the length of AB? The answer is yes. So the length of AB, we have got how much? So let's make it a different colored pen. Length of AB, I have got 600 meters. So in this triangle AMB, if I ask you to get me sine theta, because I need the length of BM. BM, which is H, is opposite to this theta. It is opposite to theta, right? And I know the hypotenuse of this triangle. So opposite is there, hypotenuse is there. These two sides are involved in the ratio sine, right? The trigonometric ratio sine contains opposite and hypotenuse. So if I ask you to write sine theta, so I'm going to take in triangle AMB, sine theta, which is opposite upon hypotenuse. So this would come how much? Sine theta would become equal to opposite, which is BM, that's H, upon the hypotenuse, which is 600. But don't we know what's the value of sine theta? Students, sine theta was 0.12, right? So I can write here, therefore, H is equal to 600 into sine theta, which is 0.12 into 600. That should give me 72 meters, right? Let's confirm it. Okay, 0.12 multiplies with 600. Of course, it's 72, but it's always better to cross check your calculation. So that's h is 72 meters. So there is a vertical displacement of 72 meters. Now along the plane, the displacement is 600 meters, but the vertical displacement is only 72 meters. This vertical displacement is responsible for the change in the potential energy. This vertical displacement is going to account for the potential energy. So I know that potential energy is given by the formula mgh. Now since the body is moving up, right, so this value so the body is going to possess more potential energy now. So this is mgh. So m is how much? So this weight of the car was 1600 kg. The mass is 1600 kg. So m is 1600 kg. So I'll write here 1600 multiplied with g. G is 10, right? G is 10, and the height, the vertical displacement of the particle, that is 72. So this multiplies with 72. So this would come out to be 1600 multiplied with 10 multiplied with 72. So it's 1152000. That's 1152000 joules, right, students? Or you can say this is Newton meter, isn't it? So mass is kg, then g is meter per second square, and h is meter. So kg meter per second square is Newton, so that's Newton meter. So potential energy is 1152000 joules, okay, Newton meter. Or you can also write this is 1152 kilojoules. Okay, so that's the potential energy that has been possessed by the system due to the change in the height. Okay, so that was part A. Of course, students, I have presented the problem in a very decorative way. Now, you need not draw a car or something like that. You can just draw an inclined plane, put up a block over there, and then find the length of AB, isn't it? And then accordingly construct the rest of the part. So presentation matters. So this is done only for explanation purpose. Now, the second part of the question. So this question is quite important, students. You want to pay proper attention while solving the question. Now, given that the total work done by the engine of the car in this time is 1960 kilojoules, find the constant force resisting the motion. Try and understand the question, students. What is it saying? Now, why is the car in motion? Are you pulling the car? Is somebody else pulling the car? Isn't it? So you want to understand this question. Why is the car in motion? The car is in motion because of the power that is generated by the engine into that car, isn't it? So that engine is doing some work to generate that power. So it is doing some work, right? And how much is the work done by that engine? So the work done in this duration, how much duration? The duration was 30 seconds, right? The distance covered is 600 meter. So to cover this 600 meter, the engine of the car has to do a work of 1960 kilojoules. Now find the constant force resisting the motion. Will there be a resistance, students, when you are driving a car? Do you feel any kind of resistance that has been offered by the road? The answer is yes, there is a resistance that is offered by the road. This resistance is the frictional force, right? So you want to overcome the frictional force. Also, can you also say that you want to pull the car, isn't it? The car will have some weight. So this weight force is also the force that needs to be overcome, right? So the car should be able to pull the entire weight. So the weight of the car, the people sitting into the car, the entire weight of the car needs to be pulled by the engine, isn't it? And it's to also overcome the friction that is happening between the tires and the road. So to overcome all these things, the engine has to work, isn't it? It has to generate power. So what is the work done given to us? It is 1960 kilojoules. So we know that the car is along an inclined plane. That's an inclined plane that I've drawn. I'm not going to draw the car now. Okay, I'll just place a block. Okay, this block is having what weight? This block is having a weight of 1600 kg, right? The block is having a weight of 1600 kg. So this, I mean mass. Okay, weight is like weight force. So this block has a weight force of how much? So the weight force is going to be 1600 kg multiplied with 10. So that's 16,000 newtons, right? So that's the weight force which is acting in the vertically downward direction. This weight force can be resolved into two components, isn't it? So I know that this angle over here is taken as theta, right? So I will have one component which is along the plane, right? One of the component is along the plane and the other component is perpendicular to the plane. So these are the two components that you want to draw, along the plane and perpendicular to the plane. So I'll just keep it over here. Okay, now you want to really understand this well. It was horizontal line, an inclined line, this angle is theta, right? And you have this force over here, this angle is 90, right? So you draw a vertical line over here, this is 90, so this angle becomes 90 minus theta, and the adjacent angle is theta. So this geometry part needs to be very clear in your mind. So I go to the diagram one more time. I know this angle is going to be theta and this bigger angle is going to be 90 minus theta, right? So there is theta and then there is 90 minus theta. So if I take the horizontal component, it is always the cos component. So I can write over here, this horizontal component is 16,000 cos 90 minus theta. But I know cos 90 minus theta is sine theta. So this comes out to be 16,000 sine theta. And what's the value of sine theta? So if you recall, sine theta was, you can recall this, 0.12, right? So this is 16,000 into 0.12. So I'm quickly going to get this value, 16,000 into 0.12. So it's 1920. Okay, 16,000 multiplied with 0.12 is 1920. So this value has come 1920 newtons, right? So I've got this component, and likewise I'll have the vertical component. So this component is going to be 16,000 sine of 90 minus theta, right? So that becomes 16,000 cos theta. If I need this value, I'll get it later. So at this moment, just leave it that way. Okay, so that's 16,000 cos of theta, the vertical component. Now the driving force, okay, the driving, so there is one concept called as a driving force. So this engine is producing some kind of driving force, right? And that's why the car is in motion. This driving force must be exactly equal to the frictional force that is going to be get generated. This frictional force is the resistive force and the weight of the car, right? So the driving force, now the car needs to go up the plane, isn't it? So the driving force should also be in the direction of the plane, up the plane. Are you getting this or not? So driving force needs to be along the plane, parallel to the plane, up the plane. I want to move the car up the plane. So the driving force should also be up the plane, not perpendicular to the plane, right? If it is perpendicular, no motion will be produced. So motion will be produced in the desired direction if the force is also in the same direction. So I will have the driving force over here. That's the driving force. Okay, this is the driving force. It is doing some work. This force is doing some work. Work done is given by what formula, students? Work done is given by force into displacement. I hope you all recall, right? So work done by the engine is given by what? It will be given by the driving force multiplied with the displacement, isn't it? So work done by the engine is going to be equal to the driving force that is getting generated multiplied with the displacement of the body. So driving force, I do not know what is this driving force, isn't it? I am trying to find it. So driving force is not known to us, but the work done by the engine is known to us. It is 1960 kilojoules. So this driving force into displacement. So displacement is also known to us. If you want, you can take that displacement, but that's not needed because I have the entire work done with me, isn't it? So the work done is given to us as 1960 kilojoules. So that's 1960 into 1000 joules. So I write 1960, 1, 2, and 3 zeros. Okay, joules is Newton meter. So I have work done by the engine. It's 196000 joules. This work done by the engine should become equal to what? This work done by the engine should become equal to work done by the engine should become equal to the work done by weight force, right, plus the work done by the resistive force, the frictional force, isn't it? So since the body is moving up the plane, the resistive force will be down the plane, opposite to the direction of motion, isn't it? So I will show the resistive force over here. That's the resistive force which is going down the plane. Resistive force. So the work done by the driving force, which is trying to go up the plane, okay, I want to pull the car up the plane, should be equal to the work done by the resistive force and the work done by the weight force. Now, by how much amount is the car moving? The car is moving by a distance of 600 meters, right? So car is moving. So distance covered is how much? Distance covered by the car is 600 meters, isn't it? So the distance covered is 600 meters. So the engine is doing a work of 1960 kilojoules to move the car by a distance of 600 meters, right? You know that work done is given by what? Force into displacement. The basic formula, work done is force into displacement. Work done by engine, I already have it. Work done by engine is 1960,000 is equal to work done by a force is the force into displacement. So the weight force, what's the weight force? So weight force is 1920 newtons, if you recall the weight force, isn't it? This is the weight force here. This is the weight force. Weight force, isn't it? The weight force which is perpendicular to the motion will produce zero work. So this weight force is in the direction of motion. So this is responsible for the work done. And this weight force is perpendicular to the direction of motion. Therefore, work done by this force is going to be zero. So we are not worried about this particular weight force. So the weight force which is taken into consideration is 1920 multiplied with by how much distance the car has moved. It has moved by 600 meters. So 1920 multiplied with 600 plus the resistive force. I do not know what that value is. That is what I'm trying to find. But the work done will be given by what? So the resistive force multiplied by the distance. So resistive force multiplied by the distance, right? So you can take out 600 common and send the 1920 on the other side. So I can simply get the resistive force equal to what? So that's 1960, 1, 2, and 3 getting divided by 600, right? 600 was taken out common and minus 1920. So I just want to simplify this now. So let's make use of the calculator. So what do we have? We have 1960, 1, 2, and 3 zeros more, divided by 600. I get some value, minus 1920. That's 4040 divided by 3. So I write here 4040 divided by 3. In decimals, it is going to be 1346.67. 1346.67. Now, as you know, that whenever you have a decimal value, you want to write it up to 3 significant figures, right? 3 significant figures. So there are 1, 3, 4, and then 6.67. So I just need the first 3 digits. So after 4, what number you can see? It's 6, right? Which is more than 5. So 1 will get added to the previous number. So this is 1350. Okay, so this is 3 significant figures. So that's what the answer is. So you should be writing this answer. Okay, so whenever you're going to make use of this force now, it should be 4040 divided by 3, and this is the answer for this particular question. Okay, 1350. So students, that was about the part B. Now, of course, again, as I said, I have given the ultimate explanation for this particular question. You need not write every single step that is being shown over here. You need not decorate it like this. Okay, you can be showing pretty basic diagram and then write the answer for this. But I'm pretty confident that this question is well understood to you, right? So that was part B. Now we're going to proceed further with part C. That's pretty simple. He just wants you to calculate the power developed by the engine of the car. How much the power that has been developed. So the formula for power, do you recall what's the formula for power? So I'll write over here, power is simply given by, so there are multiple formulas to find the power. Okay, so I'm going to mention the formulas. So the very first basic formula for power is work done divided by time for which the work has been done. So work done upon time. So I can write it W upon T. Very simple. Now you know that work done is what? Force into displacement. So I can write here force into displacement divided by time. So force is F multiplied with displacement is S denoted by, and time is T. Okay, so F into S divided by T. Now, do you know that velocity is what? Velocity is displacement upon time. So that's S upon T. So I can have the third formula as force into velocity. So that's, so here the force is the driving force, students. So this is F into velocity. So that's, these are the formulas for finding the power. So calculate the power developed by the engine of the car. So I know what is the work done by the engine of the car. So work done by the engine is how much? So the work done by the engine was 1960 kilojoules. The total work done by the engine of the car in this time is 1960 kilojoules. So that's 1960,000 joules. So I have the work done, right? And for how much time? The time is, was it 30 seconds? For how much time? TAB, 30 seconds, right? So I go here back, and time is 30 seconds. So therefore, I can very easily find the power that has been developed. So power developed is equal to work done 1960,000 divided by 30 seconds. So what's the value? So it's like 1960,000 divided by 30. It's 196 thousands divided by 3. 196, no simplification further. thousands divided by 3. Since this is power, this will be in watts. Okay, again, if you divide by 1000, that should give you 196 upon 3 kilowatts. Decimal is 65.33. So three significant figures, 65.3 kilowatts. Okay, that's what the answer is. So you can have multiple answers mentioned. This is in watts, this is in kilowatts, and this is in decimals. Okay, so that's what the question C is, part C for question number 5. Okay, now we move on to the last part of the question, which is part D. So it says that given that this power is suddenly decreased, so power is decreased by how much amount? So power is decreased by 15%. Now who is generating this power? The power is generated by the engine that is present in the car, right? So to generate this power, you have to do some work. This power will be utilized to move the car up the plane. Now this power has suddenly decreased by 15%. Okay, find the instantaneous deacceleration of the car. So as the power has decreased, the body will slow down, right? It will not stop completely, it will slow down. Okay, so if it is going to slow down, that means the velocity is decreasing. Now students, just imagine you are sitting in a car, you are driving a car, and then you want to bring the car to a halt. What will you do? You will start decreasing the power by applying the brakes to the car. Now when you are applying the brakes, is the car stopping immediately? No is the answer, right? It stops after some time, isn't it? It will take some time to come to a complete halt. Now during this journey that is happening from where the brakes are applied to a complete halt, the velocity is decreasing. It's not becoming negative. If you're traveling with a speed of 60 kilometers per hour, it will slowly come down to 50, then 40, then 25, and then slowly it will come to 0 kilometers per hour. It will not start working in the opposite direction, right? So the velocity decreases. The velocity is decreasing. That means the body is deaccelerating. I want to find this acceleration. Now, students, this is a very important stuff you want to understand. Whenever there are questions where motion is involved, okay, motion is involved, then this is kinematics. Okay, this is kinematics. And further, you also want to remember, if there is a particle involved, and then there is the forces responsible for causing the motion also involved, then it is called as kinetics. Okay, now in kinetics you have something called as D'Alembert's principle, and you have something called as work energy principle. These are two very important principles which are present in kinetics of particles. Now both the principles will give us the exact same answer. Okay, the answers are very much similar, but you want to remember very important thing. If the question demands velocity, okay, if the question says you find the velocity of the body, velocity of the particle after so and so time, or at so and so position, okay, so if the question demands the velocity, the question will never ask you which method has to be used. Okay, if it is clearly mentioned what method has to be used, then you will have to use the particular method mentioned in the question. But if it is not mentioned, see what the question is demanding. Is it demanding velocity? If it is demanding velocity, definitely make use of the work energy principle. Students, you should make use of the work energy principle to find velocity of the particle. And if the question demands the acceleration of the particle, if it is asking the acceleration, then you definitely have to make use of the D'Alembert's principle. So these two concepts you keep in mind, that if the question is demanding velocity, I will make use of the work energy principle. If the question is demanding acceleration, then I will make use of the D'Alembert's principle. In this question, what is asked? You are asked to find the acceleration, deacceleration, because the velocity is going to decrease because power has decreased. Power has decreased, so body is going to deaccelerate. So you are going to get acceleration in negative value. Okay, so I want to find the acceleration. The power has decreased by 15%. What was the power that was there? So power developed was 196,000 divided by 3, 196,000 divided by 3. watts, right? That was the power developed. It has decreased by 15%. So what's the new power? So I can write here, after decrement in the power, I can write here. So that's 15%. It has decreased by 15%. Okay. So after decrement in the power by 15%, new power is how much? New power is equal to 0.85 times, right? So decreases by 15%. So the new power is 85%. 0.85 times of 196,000 divided by 3. 196,000 divided by 3 watts. Is that clear to you? Okay. So that's what the new power is. Now you know the different formulas for power, right? So power is given by work done upon time. I'm not going to make use of work done. See, work energy principle is what I don't want to make use of, right? Then there is force into displacement upon time, but displacement upon time is velocity. Do we have the velocity of the car? So I know that the car was moving with a constant velocity of what? The car was moving with a constant velocity of 20 meter per second. So I have the velocity. So I can make use of this formula. Power is equal to force into velocity. What's that force? That force is the driving force that has been generated, right? So I can now say power is given by the driving force multiplied with the velocity, right? The driving force multiplied with the velocity. So students, I'm going to draw this diagram, okay, because I'm going to show something called as a dynamic equilibrium. I hope you all know what is a dynamic equilibrium. So when the body is stationary, we have static equilibrium, and when the body is in motion, then we have dynamic equilibrium. Because we're going to make use of the D'Alembert's principle, we will need something called as an inertia vector. Now you tell me first, what is the weight of the car? So weight of the car is 1600 kg multiplied with g, so that's 10, so that's 16,000 newtons. Okay, that's the weight force of the car. Then there will be a normal reaction that has been offered. Okay, there will be a normal reaction that has been offered. So this is the normal reaction. I say NR denoted by R. Okay, there will be a resistive force. The car is going up the plane. So I'll show the motion of the car. This is showing the motion of the car. It is not impending motion now, it is motion of the car. That's the motion, that's the direction of the motion. So if the car is moving up the plane, the resistive force will be acting down the plane. This is the resistive force which is acting down the plane. Resistive force, do we have this value? The answer is yes. What is the resistive force? So the resistive force was 4040 divided by 3. I'm going to make use of the fraction. So resistive force is 4040 divided by 3 newtons. Okay, that's a force. Okay, resistive force is there, weight force is there. Okay, of course there will be a driving force. The driving force is pulling the car up, isn't it? So I'm going to get this driving force. So I have the driving force is equal to power divided by velocity, isn't it? What's the power, students? Now it was 0.85 into 196,000 divided by 3. Let's quickly get this value. So it's 196,000 divided by 3 multiplied with 0.85. Okay, so it's 166,600 divided by 3. That's the power. 166,600 divided by 3. That's the velocity. That's the power, sorry. And you need to divide this by velocity. What was the velocity? Was it 20 meter per second? Yes, the velocity was 20 meter per second. I have to go back and check. That's 20 meter per second. So the driving force would come out to be, so whatever answer I've got, I'm going to divide it by 20. So it's 8330 divided by 3. So this is 8330 divided by 3. That's a driving force, students. So I'm going to show the driving force also in my diagram. Okay, let's show the driving force. So let's make use of an orange colored pen. So this is where the driving force will be shown, isn't it? So I'll just write it over here. This is the driving force. And how much is the quantity it has come? It is 8330 divided by 3 newtons. Okay, this was 4040 upon 3 divided by newtons. Driving force is there. What else will be there now? So you want to understand there is this weight force which I'm going to resolve into two different components. So let's quickly resolve 16,000 Newton also. You know what the inclination is, right? You already are aware of the inclination. So I'll just extend this line over here. Okay, so this inclination, or maybe I'll extend the line which was drawn previously. You can extend this line only here. And the inclination of this line is how much? This inclination was theta. This inclination was theta. Students, I'm pretty confident you are all able to understand what we are doing over here, right? You want to be very attentive, okay? So it's a long question, lot of explanation is there, so you need to be very careful with the solution. So this 16,000 Newton will get resolved into two components. Okay, let's shorten it a little bit. It will get resolved into two components. So one of the component is going to be, or I'll use a different colored pen now again. So one of the component is going to be along the plane. This is along the plane, right? So this is, this angle, if you know, is 90 minus theta. So we have done this stuff previously also. So it's going to be 16,000 sine theta. So the horizontal components are cos of 90 minus theta, cos of 90 minus theta, that's going to be sine theta. And the vertical component, if you take over here, that's the vertical component, that's going to be 16,000 cos of theta. That was actually sine of 90 minus theta, but sine of 90 minus theta is going to be cos theta, right? So that's what my FBD is, students. Now, since we are going to make use of the D'Alembert's principle, there should be one more vector added, and that is called as an inertia vector. Okay, we are going to add an inertia vector. This inertia vector will always act in the direction opposite to the direction of motion. Okay, so you want to maintain a balance. Okay, you want to bring this system to an equilibrium. The body is in motion, it cannot come into equilibrium. So what we do, we add an imaginary force. That is what D'Alembert is telling us, that since the body is in motion and you want an equilibrium, what you do is you add another force, another inertia vector, which will be acting in the direction opposite to the direction of motion, so that the body will balance. So I'm going to add inertia vector, and this inertia vector will be acting in the direction opposite to the direction of motion. So let's take one more color, and this is where the inertia vector I'm going to show. It is acting in the direction opposite. So that's my inertia vector. This is given by mass into acceleration. See, I want to find the acceleration. This is what has to be included into the diagram, the FBD, mass into acceleration. So this inertia vector is traveling in the opposite direction. Now, students, I'm in a position to take the dynamic equilibrium, summation of fx equal to 0 and summation of fy equal to 0. So I will not need summation of fy equal to 0, because it just r, and r is going to be equal to 16,000 cos of theta. Can you see the diagram? See, look at the diagram. So if you see the diagram, there is a vertical component r, and it is equal to 16,000 cos theta. These are the only two vertical components. We are interested in what? The body is moving along the plane, isn't it? So there is an acceleration only along the plane. There is no perpendicular acceleration to the plane, right? So there is acceleration along the plane. We are trying to find this acceleration, and that is present in the forces which are along the plane. So I just need summation of fx. I'm going to consider summation of fx and fy, something like this. So this is my y-axis and this is my x-axis. Okay, so I've taken this as the x-axis and this as the y-axis. So now students, what I do here is I'm going to take the dynamic equilibrium. So consider dynamic equilibrium. Okay, so what do I get? So I'm going to have summation of fx equal to 0. All the horizontal forces which are along the plane, you consider them forces. Okay, so there is this driving force which is going up the plane, taken positive 8330 divided by 3. So I write here 8330 divided by 3. That's positive. Then you have this resistive force going down the plane. So minus of 4040 divided by 3. What's next? You have this 16,000 sine of theta. Do you know what was sine of theta? Was it 0.12? Can you recall? Can you recall? Can you recall? Go back, go back, go back. And here it is. Sine theta is 0.12. Okay. So let's go back to our solution. So I know this force over here, 16,000 sine of theta, that is also along the plane. Okay, and sine theta was 0.12. So 16,000 into 0.12 and going down the plane, so negative. So minus of 16,000 into 0.12. What else is there? So total, how many forces are there? There was a weight force going down the plane, 16,000 sine theta. There was a resistive force going down the plane, 40 divided by 3. There was the driving force going up the plane, 8330 divided by 3. And there is one more force which is called the inertia vector, given by mass into acceleration. Mass is 1600 kg into the acceleration which I'm trying to find. So this is, and going where? Down the plane, right? It is going down the plane. So minus of 1600 into the acceleration. This is what we want to find. This is what we want to find. And this is all equal to what? 0. What happened? Is equal to 0, right? So can you now solve the equation, send the 1600A on the other side, and then divide the entire equation by 1600. So I'm going to get acceleration equal to, so I do 8330 divided by 3 minus 4040 divided by 3. I get some value 1430 minus 16,000 multiplied with 0.12. I get some answer, that's minus 490. And that 1600A has gone on the other side. So that 1600 multiplied with A, 1600 will go in the denominator. So divide by 1600. That gives you minus 49 upon 160. Minus 49 upon 160, which is minus 0.30625. I want to write the answer with 3 significant figures. So my answer for the acceleration is going to be minus 0.306 meter per second square. That is how we complete our question. Students, I know this question was slightly tricky, but I'm pretty confident that you must have understood the entire solution, how the question was solved. So D'Alembert principle is a very important concept of mechanics. You need to know how this question needs to be tackled. So that was all about this question. This was question number 5, right? All the 4 parts have been solved. So the first part was for 3 marks, second again for 3 marks, next again for 2 marks. That's 8 plus 3, that's 11 marks. That's pretty serious, isn't it? So it's time for us now to move on with the next question. We will go further to the next question. It's question number 6. The next question is again a question on motion curves. You can observe the question says a particle P moves in a straight line starting from a point O and comes to rest 14 seconds later. So the total duration of the journey of the particle is 14 seconds. It is starting from a point O. So starting from a point O, so I will say point O becomes the origin and it comes to rest at 14 seconds. So when I say comes to rest, it means the velocity has become 0 when t is 14. Okay, now it is also told that at time t seconds after leaving O, the velocity v meter per second of p is given by. So there are two equations given to us: v equal to pt square minus qt when t is lying from 0 to 6 seconds, and v is equal to 63 minus 4.5 t when t is lying from 6 to 14 seconds. Okay, where p and q are positive constants. The acceleration of p is 0 when t is 2. Now this is a very important information that has been provided into the question. The acceleration of p is 0 when t is 2. Given that there are no instantaneous changes in velocity, find the values of p and q. That's for 3 marks. Sketch the velocity time graph. That's for another 3 marks. Find the total distance traveled by p during the 14 seconds. That's for 5 marks. So students, a pretty big question. 5 marks, 3 marks, and 3 marks. So that's 11 marks again. So let's begin solving the question. So it says that a particle P moves in a straight line starting from a point O, okay, and it comes to rest 14 seconds later. At time t seconds after leaving O, the velocity v meter per second of P is given by. So there are two equations given to us. So v is equal to what? So I'll just write quickly the equations. So you are given v is equal to pt square minus of qt when t lies from 0 to 6 seconds, and 63 minus 4.5 t when t lies from 6 to 14 seconds. Okay, so I have two equations. You want to now proceed further. He says that the acceleration of p is 0 when t is equal to 2. I have the velocity. Now where is t equal to 2? T equal to 2 lies in the first region, right? T equal to 2 lies in the first region. The first equation that is given to us, t equal to 2 lies within the range 0 to 6 seconds. So when t is 2, velocity is what? Velocity is pt square minus qt, and it is told to us that the acceleration is 0. Students, don't you recall acceleration a is dv upon dt, isn't it? Very basic formula. Acceleration is given by what? Dv upon dt. I have the velocity v, it is pt square minus qt, isn't it? So I can say, since acceleration a is 0 meter per second square when t is 2 seconds, we know at t equal to 2 seconds, what's the velocity? Velocity is p t square minus of qt. Let's differentiate both the sides. Let's differentiate both sides with respect to t. So I get dv upon dt is equal to p times of 2t minus of q times of 1, right? So derivative of t square is 2t and derivative of t is 1. But I know dv upon dt is acceleration, isn't it? It's already written over here. Dv upon dt is a, and at t equal to 2, what is the value of a? It is 0. So I can write here, therefore acceleration a is equal to 2 pt minus of q. So substitute a equal to 0 when t is equal to 2. So I get 0 is equal to 2p into 2 minus q. So that's 4p minus q equal to, so I'm going to call this as equation 1. Let's call this as equation 1. 4p minus q equal to 0 is my equation 1. So I will need one more equation, students, isn't it? I will need one more equation to get my answer. Now, what is told about the particle? It comes to rest at 14 seconds. Also, initially, when the particle is going to start, okay, the time is t equal to 0. So at that time also the velocity is going to be 0. Now when velocity, when time is 6 seconds, when time is 6 seconds, what is the velocity given to us? So I can have at t equal to 6, velocity is given by pt square minus qt. Can you see t is equal to 6 given to over here, and t is equal to 6 in the next equation also. It is 63 minus 4.5t. So at t equal to 6, what can I write, students? At t equal to 6, at t equal to 6, v is equal to both the equations, isn't it? First equation is what? First equation is pt square minus qt, pt square minus of qt, and at t equal to 6 seconds, the other equation is 63 minus 4.5t. 63 minus 4.5t. Therefore, so at a particular time, at a given instant, a particle cannot have two different velocities, isn't it? The particle needs to have exactly same velocity. So the first equation and the second equation, pt square minus qt and 63 minus 4.5t, both these equations at t equal to 6 will give exactly same answers, right? So at t equal to 6, v is pt square minus qt and v is also 63 minus 4.5t. So I can write, therefore, p times of t is how much? 6 square minus q times of t is how much again? 6, is equal to 63 minus 4.5 into t is 6. So I can divide throughout by 6, or maybe first of all, I'll simplify this as 36p minus 6q is equal to 63 minus 4.5 into 6. That gives me 36. I can divide throughout by what? Divide throughout by 6, isn't it? So I get my equation as 6p minus q equal to 6. I'm going to call this as equation 2. So now, students, can you solve equation 1 and 2 simultaneously to get the values of p and q, isn't it? So I can subtract the first equation from the second equation, or you can simply write the value of q as 4p, right? So substitute q is equal to 4p from equation 1 to equation 2. So therefore, I'll be getting what? 6p minus q is taken how much? It's 4p. It is equal to 6. So that gives me 2p is equal to 6. So p is equal to 3. That's my first part of the answer. I've got the value of p. And now I'm going to substitute p equal to 3 in any one of the equation to get the value of q. First is more better. So I can write here, substitute p as 3 in equation 1. So that should give me q is equal to 4 times of p, 4p. So q simply becomes equal to 12. So I've got the second part of my question as well. So p is 3 and q is 12. So now can you write v again with the values of p and q, 3 and 12? So I can write p is equal to what? Therefore, p, not p, sorry, v is equal to, so it was pt square, p is 3, 3t square minus qt, which is 12, 12t, right? And t lies from 0 to 6, 0 to 6. I needed two equations. Students, there are two unknowns, p and q. So for two unknowns, you will need two equations. So the two equations were brought from where? First condition was acceleration was 0 when t is equal to 2 seconds. The second condition is hidden over there. It's not clearly mentioned. It's very deceptive over there, isn't it? So they have not clearly mentioned from where to get the second condition. But we know, we are smart, isn't it? We saw the limits. Both the limits got me t equal to 6, t equal to 6, isn't it? So from there, I can easily identify that the velocity of the particle at t equal to 6 from both the equations is going to be same, right? So that was my first equation. The second equation is 63 minus 4.5t. 63 minus 4.5t. This is from t where to where? 6 to 14 seconds. Okay. So that is your equation. That is your velocity equation. Okay. So I'm going to make use of this equation to sketch the velocity time graph. So we have already completed the first question. Now we are advancing towards the second question. Sketch the velocity time graph. So v versus t graph is needed. So v will be on the y-axis and t will be along the x-axis. So I'm going to draw the velocity time. So you can observe when t is 0, velocity is 0. So what I'm going to do here is I'm going to construct an equation in my calculator. Okay, 3t square minus 12t, and from 0 to 6, 0, 1, 2, 3, 4, 5, and 6, I'm going to take these values. And then 63 minus 4.5t, you can take 6, 7, 8, 9, 10 up to 14. Okay, so you can observe I'm going to create an equation. So I write 3. Okay, write 3. I'm going to teach you this also. Write 3. Then press the alpha key that you have on the calculator. After 3, you press the alpha key, and then press the close bracket where you have x written over the close bracket. So that will give you 3x. It will look like this, 3x, and then minus sign, and then so you need t square. So not minus sign, t square. So you're going to press the square button. So it looks like this now, 3x square minus of 12t. So that's alpha and close bracket. So the equation should look like this. I am pretty confident that the equation is visible to all of you. 3x square minus 12x. Now what you do is you can see the calc button over there, isn't it, in the second row? So there is a calc button. I'm going to press that calc button. So press the calc button. It asks for x, right? A question mark, and then 0 is there. Okay, sometimes that in place of 0 you can have some value. So x and then question mark. Do not worry about the value. It is a previous answer. So it will just ignore, the calculator will ignore that value. So you want to feed that value now. So you can start from 0, 0. Of course, the answer is going to come 0, then 1, 2, 3, and so on. So when I press 1, see, I've pressed 1 and then press the equal to sign. The answer came -9. The answer is -9. So what I'm going to do here is I can see that the answer has come negative. Okay. So the velocity time graph, velocity is negative, -9. So I will need to draw the diagram in such a way that the velocity will go down also. That's -9. Okay. So I draw the vertical line. That's the y-axis on which v is going to get represented. So this is v, meter per second. Then I want to also draw the horizontal line on which time is going to come. So I have for -9, no, not for -9, for 1, when t was 1, okay, I've got -9. Then I'm going to put 2. Okay, I'm going to put 2. I've got -12 for 2. For 3, I again got -9. For 4, I got 0. For 5, I've got 15. For 6, I've got 36. So this was obtained originally also. So I have to go from -9 towards 36, right? -9, -12, -9, 0, 15. They're all multiples of 3, isn't it? They're all multiples of 3. So you can take a table of 3, 36. And then what happens after 6? The equation changes. Now, can you see you have a quadratic equation here. This is a quadratic equation. This is a quadratic equation, isn't it? So your graph, the VT graph, will be parabolic in nature. The VT graph will be second degree equation, parabolic in nature. Okay. And I have the points over here, -9, -12, -9, 0, 15, 36, from 0 to 6. And then from 6 onwards up to 14. So I'll just take a few points from 6 to 14. There is no need to take every single value. At 14, it is going to be 0. At 14, it is going to be 0. So what I do here is I just draw a horizontal line. I'm going to draw a horizontal line over here. Let's draw a horizontal line like this. You can extend further. Okay, that's a horizontal line. And you can take values from 0 to 14. So this was 0. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Okay, so for 6, I know it is 36. For 6, it is 36. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. And at 14, the velocity has to come 0. And then I can also take this is -3, then -6, minus 9. I'll have 3, 6, 9, 12, 15, 18, 21, 24, then 27. I'll have to go up. 27, then what? 30, 33, and then 36. So I'll have to remove this as well. So this is where 36 is going to come. Let's extend this line a little bit. Okay. And we'll mark this as the v-axis. Okay, the y-axis, it is meter per second. So let's plot the points very quickly. Okay, so I know for 0 it was 0. For 1 it was minus 9. So it is here. Then minus 12. So I'll have to go a little bit down over here. That's minus 12, isn't it? So for 2 it was minus 12. So somewhere here. And then for 3 it is again minus 9. So here. Then for 4 it is 0. So this is 0. So the graph is going to come like this. Got it? Okay, quadratic. Okay, so it's a parabolic graph. And then from 4 it is going to go to 5 when it is 15. So I'll just take a faint line. This is 15 line, this is 5. So it's somewhere here. I'm going to erase these lines. Okay. And then for 3 it was 36, right? No, not 36. For 6 it was 36. So this is 6 here. This is 6 over here. This will go to 36 like this. Okay. And again, for the line, it was again 6 to the minus 4.5 t. For t equal to 6, it was again 36. So no need to do this, isn't it? And for 14, it is going to come 0. You can check. 63 minus 4.5 into t is 14. You simplify this, the answer is going to come 0. So from this point, you'll have to come to 14 straight away like a linear line. Okay, it has to come like a linear line and it will attach at 14 and the answer is going to be 0. So I am going to extend my curve, this one, so that it goes and meets the point of 36. Okay, somehow like this. Remove the rest of the lines, not needed. And then from here, what's going to happen is also let's remove these values also, don't need them. From here, from this point, you will have to come to 14, t equal to 14, where the value is going to be 0, right? The velocity is going to be 0. You can calculate. So this is how the graph has to look. So this is linear. This is linear, right? Velocity is linear because you had a linear equation, 63 minus 4.5. This is a linear equation. And then this is parabolic. This is parabolic. So you should mention these things in your graph, students. So at t equal to 6, what's happening? So t equal to 6 is the bifurcating line. It is distinguishing your graph into two parts. This is where t equal to 6 is, right? Okay. You can just rearrange slightly over here. That's your line of t equal to 6. Got it? Now, I can name this. So this was origin. This point you can take as this lower point can be taken as A. Okay, let's take that point as A. This point is A over here. Then you can name this point as B, this highest point as C, and this point as D. If you want, you can name this point also as maybe E. Let's name this point as E. Okay, so that's how the graph is. So for this, you are going to get another 3 marks. Got it? So B part is done. Now find the total distance traveled by P during the 14 seconds. That's the C part. Now, very interesting question, students. I hope you remember the previous question that we have solved, isn't it? I've already told you that if you have 80 graph, 80 curve, from 80 curve, if you want to get the VT curve, so you just want to get the area under the curve. From VT curve, if you want to get the XT curve, that means a displacement curve. So again, you want to find the area under the curve, right? You simply want to get the area under the curve. So that will simply give you the XT graph. Here, XT graph is not needed. What I need is the total distance that has been traveled by the particle in this 14 seconds. So what I need to do, I just want to find the area under the curve that is given over here. Now be very careful. The part OAB is below the x-axis. This was T. I forgot to mention here. I just mentioned it here. This is T and it was in seconds, right? T was in seconds. So you can now see that this portion OAB, you can see portion OAB, right? There is point O, there is point A, there is point B. So this portion OAB that you have is below the x-axis, below the t-axis. So this will give you negative area. This will give you negative area, but displacement cannot be negative. So displacement can be negative. Distance covered cannot be negative, right? Distance covered cannot be negative. So that's why whatever answer you'll be getting for this OAB area, okay, that should be taken positive. Remember this concept very clearly, students. You have this part OAB, which is below the t-axis. T-axis is your x-axis. So if you find the area under the curve, so area under the curve is going to come negative, but area under the curve is going to give you the distance that has been traveled by the particle, and distance cannot be negative. That's why we're going to consider the modulus sign. Okay, distance covered has to be obtained. If the question was to find the displacement, then I would have considered the negative sign. Okay, so I want to find the area under the curve. So OAB is one part where I want to find the area. It is the area under the parabolic curve. So I will need to shade the region. Okay, I'll need to shade the region. So this is the region that I want to shade. Okay, this is the region that I want to shade. This is the area under the parabolic curve below the x-axis. Okay, this is below the x-axis. This is below the x-axis. Okay, this is the area which is going to come negative. This area is going to come negative, but I will consider the positive area. So this is area under the curve, area under the parabolic curve. This is the area under parabolic curve, area under parabolic curve, and it's going to be kept in the modulus sign. Why? Because it's going to come a negative answer. Fine. This is the first area that I want to find. Now, what is the equation of this curve? So equation of the curve is 3t square minus 12t. This equation is 3t square minus 12t. That's the equation of the curve. So area under the curve is integration. I'm going to integrate. That's all I need to do. Then the second part is this one. Okay, this is looking like a triangle, but it is not a triangle, students. You want to be very careful with that. Even though it looks like a triangle, this area is not a triangle. Okay, this area is also the area under the parabola. What happened? This area is also the area under the parabola. Okay, so I'm going to shade this region one more time. That's my region. Okay, so this is again the area under the parabola. Okay, but this time the area will be positive, so no need to consider the modulus sign. So this is again area under the parabola. And you know what the equation is? 3t square minus 12t. So here t is lying from where to where? For this region, t is lying from 4 to 6 seconds. For this region, t is lying from 0 to 4 seconds. Okay, very important limits is what I have considered over here. And the last portion, students, the last portion can be easily understood. This portion that you can see, this portion is the area under what? This is the area under the line, isn't it? This is the area under the line. This area is the area under the line. Got it? So I'm going to shade this region as well. Let's shade this region. Let's quickly shade this region. Okay, so this is area under the line. And what's the equation of the line? 63 minus 4.5t. 63 minus 4.5 t. So either you can make use of integration. So t lies from where to where? T lies from 6 to 14, or you can simply say you are going to find the area of the triangle, right? So this is a area of a triangle. But again, students, the portion BEC that you can see, there is point B, there is point E, there is point C. This portion BEC is not a triangle. It looks like a triangle, but it's not a triangle. It is area under the parabola. So you want to do integration there. But for the region CED, you will not need to do the integration. We're going to save time over there. Okay, we can simply use half base into height because it's a triangle and the area of the triangle is half base into height. Even if you use integration and integrate the equation 63 minus 4.5t, you want to integrate 63 minus 4.5t from the limit 6 to 14, you still end up with the same answer. So let's be smart. Let's not spend our time in integrating the area under the line. You just use the formula for area of a triangle. So total distance traveled, total distance traveled will be area under the parabolic curve whose equation is what? 3t square minus 12t. 3t square minus 12t, right? For t lying from 0 to 4, because it was below the x-axis, the t-axis over here, right? So this is going to be a negative answer. So I'm going to keep this in a modulus sign. Let's keep it in the modulus sign. So the answer will become positive. Okay. Then plus the next part is again area. So I'm going to write same area under the parabolic curve. Equation is same, right? But t is lying from where to where? T is lying from 4 to 6 seconds. No need to put a modulus sign. And plus area of triangle. Something is going wrong. So area of triangle CED, right? Area of triangle CED. So area of triangle CED. So here what's the base for the triangle CED? Base is going to be from 6 to 14. That's 8 units, isn't it? That's 8 units. And the length of CE. So if you remember, length of CE was 36. At t equal to 6, it was 36. So this is the height. And it is 36 units. Okay. So let's begin. So even if you do integration, you're going to get the same answer. So I write integration of t equal to 0 to t equal to 4. And what you want to integrate? 3t square minus 12t dt. And we'll keep this in modulus sign. Okay, you're going to keep this in modulus sign like this. And then plus integration t equal to 4 to t equal to 6. Again, you want to integrate the same equation. 3t square minus 12t dt, right? And finally, if you want, you can integrate, you can cross check this for yourself. Okay, I'm not going to do this. This is t equal to 6 to t equal to 14, and your equation was 63 minus 4.5t. You do the integration, 63 minus 4.5t, and you can cross check whether I'm correct or not. Okay, so that's a homework. So I'll be getting what? So the first equation is 3t square minus 12t, or better I should say expression. You want to integrate this. So integration of t square is t cube upon 3. So integration of t square is t cube upon 3. So that's 3 t cube upon 3 minus 12. Integration of t would be t square upon 2. And the limits are from where to where? T is equal to 0 to t is equal to 4. And this will be maintained within the modulus sign. Make sure that the first answer is maintained in the modulus sign, since you're finding the area. And then you'll be taking plus, again put a bracket, integration of again 3t square minus 12t, it's going to be same, 3t cube divided by 3 minus of 12t square upon 2. But this time the limits are what? T equal to 4 to t equal to 6. You can try out for the last one, but I'm going to make use of half base into height. Half base is 8, if you recall. Height was 36, so half of 8 into 36. Let's simplify it further. So you can easily see that the 3 and the 3 will get cancelled, 2 and 12 cancel, you get 6 here. Same happens for the second bracket as well. So my simplification would give me t cube minus 6t square. Limits are from 0 to 4 within modulus sign, plus second one is t cube minus 6t square. Limits are from 4 to 6, and plus, so that's 1 upon 2 multiplied with 8 and 36. So that's 18 times of 8. That should give you 144. So that's plus 144. Great. Now put the upper limit and the lower limit in all of the conditions. So when you put upper limit in the first one, you get 4 cube. So 4 cube is 64. 64 minus 6 times of 16, that's 96. See, the answer is coming negative. And for the lower limit, the answer is going to be 0. Keep in the modulus sign, then plus. Again, 6 cube. So 6 cube is 216. Minus, that's the upper limit. 6 into t square. T square is again 6 square. So that's again going to be 216. That's the value for upper limit. Minus the lower limit. So 4 cube, that's going to be 64. Minus 6 times of t square. So that's again going to be 96. This was the second term. Okay, no need to keep the modulus sign over here, because here what's going to happen is the positive answer is going to come plus 144. So 64 minus 96. 64 minus 96 gave me minus 32 inside the modulus sign. So I write plus 32 over here, plus 216 minus 216, that's 0. Minus again minus 32, that becomes plus 32 and plus 144. So the answer comes 32 plus 32 and plus 144. The answer has come 208. It is 208 meters. That's what your answer is. The displacement, the total distance traveled, I should better say. The distance traveled is 208 meters. So it was a very, very important question, students. I'm pretty confident that the question is well understood by you. It's time for us now to move on to our last question, question number 7. What does it say? So you can see that there are two particles A and B of masses 2 kg and 3 kg. So mass of A is 2 kg given to us, mass of B is 3 kg. They are connected by a light inextensible string. So when it says light, it means the weight of the string has to be ignored, it's neglected. Inextensible, that means there is no stretching into the cable. Particle B is on a smooth fixed plane. So when I say smooth, that means there is no friction between particle B and the plane on which it is resting. The plane is inclined at an angle of 18 degrees to the horizontal ground. That can be seen from the diagram. The string passes over a fixed smooth pulley. So when I say smooth pulley, there is no friction at the pulley as well. This pulley is at the top of the plane. Particle A hangs vertically below the pulley and is 0.45 meters above the ground. Okay, so you can see the diagram, it is mentioned that particle A is 0.45 meters above the ground. The system is released from rest with the string taut. When A reaches the ground, the string breaks. Okay, now this is very important. So initially the system was at rest. the system is in the position that is shown in the diagram. From there I release the system. So you can see that point A is going to go in the downward direction, right? Point A will go downward direction, and it will start pulling the particle B. So particle B is going to go up the plane. Okay, so point A will go down the plane, point B will go up the plane. So the system is released from rest with the string tout when A reaches the ground. So A is going to reach the ground. That means definitely the motion is the way I have told you. Now the string breaks. So when A reaches the ground, the string breaks. Okay, but now B is already in motion. A has come down, it has reached the ground, and the string has broken. Okay, when A touches the ground. As soon as the string gets broken, now since A has pulled B up, B is into some velocity, right? B is having some velocity of its own. So B will not stop suddenly. B will not stop suddenly because there is no friction. Okay, there is the surface is smooth. So B will continue for some time. B is definitely going to continue for some time. But there is gravity acting on the particle B. This gravity will not allow particle B to travel in the upward direction forever, right? After some time, B will stop, and from that place, it will start coming back. Okay, the journey will reverse. What is asked in the question? Find the total distance traveled by B before coming to instantaneous rest. Did you see the question? So find the total distance traveled by B. So B is going to first go up, okay, because A is going to go down. A goes down by how much amount? 0.45 meters. A goes down by 0.45 meter. A is connected by a string to B, isn't it? So A and B are both connected to the string. So since A and B are both connected to the string, A and B are both connected to the to each other by the string, whatever distance A will travel, exactly same distance B will also travel along the plane because it's the same string, right? So the string is inextensible. The length of the string is not going to change. So if the string displaces by 0.45 meters, A displaces by 0.45 meters, B also displaces by 0.45 meters up the plane. So that is very important over here. Now, as I said, particle A is coming down, it is pulling B up. So B has got some velocity now. Okay, and as soon as A reaches the ground, the string breaks, but B will still continue its journey in the upward direction for some time because there is no friction, and then but the gravity is acting on it. So when it reaches at a certain point, there it will stop for a moment and then will start sliding down. So that's what you want to find. What is the total distance covered? So of course, some part is already known to us. Some distance is 0.45 meter. That I already know. B is going to continue for 0.45 meters because A is going down by 0.45 meters. From there, I want to discuss what happens to the particle B, how far it can go without the support of A. Okay, and then it will come for a rest for an instant, and then it will start coming back again. It is also mentioned that you may assume that B does not reach the pulley. So can you see? So even though B is going to go up the plane, it will not reach the pulley. Okay, it will stop in between somewhere, and from there it will start its journey backwards. But we are not interested what happens when it comes back, because since there is no friction, it will keep on sliding down till infinity. Forever it will keep on falling down. Okay, so no point in discussing when it comes down. So we want to start from the given position. It will go 0.45 meters, and from there it will continue its journey up. Got it? So this question is for 8 marks, and I can solve this question in 2 different methods. And students, I'm definitely going to discuss both the methods with you. Okay, so I can solve this question by D'Alembert's principle, and I can solve this question by work energy principle as well. Okay, so that covers both the concepts, the D'Alembert's principle and the work energy principle. Also, your marking scheme will contain most probably both the solutions. Okay, fine. So let's begin. So what I'm going to do here is, initially particle B will come at this particular place, right? This is where particle B has come, and particle A will reach here, isn't it? That's the positions of particle A and B. This is A, this is B. So how much is the distance covered by B? So the distance covered by B is 0.45 meters. So initially I'm going to make use of the D'Alembert's principle. Okay, and then we will solve the same question by work energy principle as well. So according to D'Alembert's principle, what's happening over here? Now, before I start with the question, I also want to mention one very important law, which is called as the string law. How many strings are attached to the body? So for body B, for the particle B, there is one string attached. For particle A, also one string attached. The string law says the number of strings attached to particle A multiplied with the acceleration of A is equal to the number of strings attached to particle B into the acceleration of B. So this is a very important formula, the string law. N of A into acceleration of A should become equal to N of B into acceleration of B. This is called as the string law, students. Since the string is inextensible, the string law is applicable over here. So how many strings are attached to particle A? Only one. And how many strings are attached to particle B? Again one. So that's 1 into acceleration of A equal to 1 into acceleration of B. So I can write over here acceleration of A is equal to acceleration of B. Let us say it is equal to A meter per second square. So A and B are both traveling with exactly same acceleration. If I now I can also write like this, I can write few more statements. So N of A multiplied with X of A is also equal to N of B multiplied with X of B. So XA and XB are the displacements of particles A and B. And second one would be when you differentiate this, you get NA, which is constant, right? Number of strings attached is constant, multiplied with derivative of X of A. So derivative of displacement is velocity. So this is going to be VA is equal to N of B times VB. And you definitely know the third one also, N of A into acceleration of A will become equal to N of B into acceleration of B. So here I know that particle A and particle B, both of them are having the exact same acceleration, okay, using the string law. So that's A meter per second square. So what I'm going to do here is I'm going to take the first case when the particle travels by a distance of 0.45 meters. I know point B, particle B has traveled by a distance of 0.45 meters. I'm going to make use of the D'Alembert's principle. After that, what happens is the string breaks. Now only particle B will travel further. Okay, so there are two different conditions you want to discuss. In the first condition, A and B both are traveling, and the second condition, only B is traveling. In both of the conditions, you want to apply the D'Alembert's principle. So I'm going to make a small diagram. Okay, so first what I'll do is I'll construct the FBD of B. So let's draw the FBD of particle B over here. So I can see that particle B is along an inclined plane. Okay, so I'm going to draw a line over here like this. It's an inclined plane. I just pick that line and I bring it over here for perfection. So that's my line. And on this line, you have particle B resting. Okay, so what I'm going to do here is I'm going to make a block. Instead of making a particle circular diagram, I'm going to make a block. So I have this block. This is block B, and you want to introduce all the forces. Okay, it is kept on a smooth plane. So smooth plane, so friction is not going to be there. So the first thing that you want to pay attention for is the weight, right? So weight will be acting in the vertically downward direction. That's the weight. So the mass was 3 kg. So weight is 30, right? It's 3 into 10. So it's going to be 3 multiplied with 10. That's 30 newtons. Okay. You can resolve this. We'll resolve it in a short while from now. First of all, let's take all the forces. Okay. Now, will there be tension? It is attached to A. So there will be tension, right? The string is attached like this. So the string will be in tension. So this is T. Okay. This is T. So when you go over here, this B and A, they are both attached via the string. So on either side of the string, there will be a tensile force. Okay, so T is the tension. So you have T, then of course normal reaction is going to be there. Normal reaction is going to be there, even though it's not going to play any important part over there because there is no friction over here. Okay, but we should show the normal reaction. This is the normal reaction. Normal reaction, you can denote it by R. Okay, so normal reaction R is there. Then T was there, and the weight force is there, right? We are using the D'Alembert's principle. So you want to find out how many forces are acting on the particle. So on the particle, weight force is there, the normal reaction is there. Okay, and I will call this as RB if you want, because it is for particle B, RB. Okay, and the tensile force is there. Nothing else is there, right? So you can now resolve the forces. Students, you can resolve the forces. You know that the inclination is 18 degrees over here. This horizontal line you can draw, and this angle is given to you 18 degrees. So I'm going to resolve the 30 Newton force. Okay, so one component will be along the plane like this. One component is along the plane. So this component is going to be the horizontal and the vertical component. You know that this smaller angle, this angle is 18 degrees, right? That's 18 degrees. So this angle will be 90 minus 18. So very quickly, 90 minus 18. So of course I can get it orally, but I usually prefer getting it on a calculator so that we don't make any foolish mistakes. So that's 72 degrees. So one of the component is going to be 30 cos 72 degrees, and the vertical component is going to be 30 sine of 72 degrees. Okay, so I've got the two components. Now, where is the impending motion, or where is a particle moving? So we know that the particle is going up, right? That's what the direction of motion is. This is where motion of the particle is. If the particle is moving up, then I need to get it into dynamic equilibrium. So I should be adding an inertia vector, and the inertia vector will be acting in what direction? The inertia vector will be acting in the downward direction, right? So I'll put up an inertia vector over here. That's an inertia vector. The question is for 8 marks, so plenty of things are expected by the examiner from you. So that's your inertia vector. It is given by mass of B into acceleration of B. So do you know what is mass of this? It was 3 kg, and acceleration is taken as A. So this is 3 times of A. Okay, so no point in taking summation of Fy, because it will simply give you the value of Rb, and we are not utilizing Rb anywhere since there is no frictional force. So no point in taking summation of Fy equal to 0. But we do need to take summation of Fx equal to 0. So let's consider summation of Fx equal to 0. So when I take summation of Fx equal to 0, what things I'm going to get? So T is going up the plane, taken positive. 30 cos 72 is going down the plane. So minus of 30 cos of 72 degrees, right? And then the inertia vector also going down the plane. So minus of 3a. So I write minus of 3a equal to 0. So I've got the equation T minus 3a is equal to 30 cos of 72 degrees. That's my first equation. That has been obtained from the FBD of what? FBD of particle B. So this was FBD of particle B. Now let's draw the FBD of particle A also. FBD of particle A. Okay, so again I'm going to make a block. This is a pretty simple one. Okay, particle A is quite simple because there are not lot many forces acting on block A. This is block A. So this block A is attached by a string. The string is in tension. That's T. The weight of the block will be acting in the downward direction. So weight of the block, the mass of the block is how much? 2 kg. So weight of the block will be 2 into 10. That's 20 Newton. That's the weight force. And where is the block A going? motion is downwards, isn't it? Motion of the block A is downwards. That's where the motion is. If motion is downwards, where will the inertia vector be? So inertia vector will be in the upward direction. So let's quickly show the inertia vector. Let's quickly show the inertia vector. Inertia vector will be in the upward direction, isn't it? This is the D'Alembert's principle. Remember very properly. So that's your inertia vector. Okay, it will be mass of A into acceleration of A. So what's the mass of A? It's 2. Acceleration of A is taken as A because acceleration of A and B was very same. Now there is no x component over here, right? Only summation of Fy is going to come. So I'll be considering summation of Fy equal to 0. So I have T going up, so taken positive. I have 2A going up, also taken positive. I have 20 going down, so minus 20 is equal to 0. So I've got my equation as T plus 2A is equal to 20. That's my second equation. So I'm going to solve first and second equation simultaneously. Let's solve 1 and 2 simultaneously. So solving 1 and 2 simultaneously. Okay, so I'm going to get the value of T. So I'm simply going to make use of the calculator's equation mode. Okay, so let's go to the equation mode, and in that you select simultaneous equation with 2 unknowns. Okay, so what's the coefficient of T in the first equation? It's 1. So enter 1. Coefficient of A, it's minus 3. And the constant on the other side, 30 cos of 72. Okay, so can I enter this value over there? Then what's the coefficient of T in the second equation? That's 1. And then coefficient of A is 2. And the right hand side is 20. Okay, so if you simplify, T has come 15.7082. So I'll just write 15.71. 15.71 newtons. That's the value of T. And the acceleration, which is the acceleration of A and the acceleration of B before the braking has happened, it's 2.145898. So I can simply write 2.146, right? So acceleration is 2.146 meter per second square. So I have got the acceleration of both block A and block B, particle A and particle B, just before the braking is going to happen. So I have the acceleration. Can I get the velocity? Can I get the velocity now, students? I know the acceleration. I know that the particle is going to travel for how much distance? The distance traveled is 0.45 meters. Do you recall that? The particle B was traveling up the plane. It will cover the exact same distance as the distance that has been covered by particle A while going down, 0.45 meters. So I know for how much distance it is traveling, isn't it? So I can get the velocity of particle B just before the braking is going to happen. Okay, so initially the velocity of particle B is how much? So if I draw the diagram one more time, like this is 18 degrees. This is particle B over here. I just make a small block. Particle B initial velocity is how much? 0 meter per second. And the final velocity I am trying to find, this is VB. Okay, I don't know what that value is, this particle B. But I know the distance traveled is how much? The distance traveled is 0.45 meters. This is 0.45 meters. I now have the acceleration also, isn't it? I have the acceleration. So we know V square is equal to U square plus 2AS. V square is equal to U square plus 2AS. So I can get V square is equal to initial velocity 0 square plus 2. Acceleration is 2.146 into the displacement, which is 0.45. So I've got the value of V square from here, students. So I can get the value as 2 into 2.146 into 0.45. It has come 1.9314. V square has come 1.9314 So I can also get the value of V. Just take the square root of this answer. It's 1.38975. 1.38975 meters per second. So I have got the velocity of B, right? Velocity of B just before the particle A is going to break, right? This is the final velocity of B. Now it will continue its journey for some time. Okay, it is going to continue its journey for some time, and then what will happen? It will come to a halt, right? So now there is no body A, particle A is not there, only particle B is there. So if you now take particle B, I know the velocity, I know it's 1.38975 meter per second. This is what it is going to start its journey with, and it is going to end its journey at what velocity? Final velocity is going to be 0 meter per second. But again, I have the velocity, I want to find the distance traveled, but I don't have the acceleration. I know V is equal to U plus AT. I know V square equal to U square plus 2AS, isn't it? I can make use of V square equal to U square plus 2AS. V square equal to U square plus 2AS. For that, I will need the final velocity, which is 0. I'll need the initial velocity. I know after A has broken, okay, after A is separated from B, what is the velocity? That becomes the initial velocity now for the second part of the journey. So I have this value. I do not know what is the acceleration now. Acceleration is not going to be same, right? The body will have a different acceleration now. So I will just consider the FBD of particle B, and I'm going to apply the D'Alembert's principle. Okay, now there is no tension. There is nothing now. Okay, the string is slack. Initially the string was taut, now it is slack, so there is no string attached to it, so there is no tension because of the string. So I again make the FBD of particle or body B. Okay, so it was kept on an inclined plane, which is inclined by an angle of 18 degrees. You can simply make a block very quickly over here now, because it's a big question. For 8 marks it is. So now there is this vertical weight force. Okay, if you recall, it was 30, isn't it? It was 30 newtons. Then there are two components. This is 30 newtons. There were two components. Very quickly, let's make those two components. The horizontal component, right? That's the horizontal component, and there will be a vertical component. So the vertical component is going to be what? It is going to be 30 sine of 72. 30 sine of 72. So that's 30 sine of 72, and this is 30 cos of 72 degrees, right? And then, of course, you'll have a normal reaction. This is a normal reaction. I can call it as RB. No tension, but there will be what? There will be a inertia vector. Okay, so the block is still going up. Motion is upwards. So I'll just write here, motion is up the plane. Motion is up the plane. So the block will go in the downward direction. Not the block, sorry. The motion is upwards. The inertia vector will go downwards. This is the inertia vector, and that's mass of B into acceleration of B. Remember, it's not the same acceleration now. There is no pulling by A. Okay, it's just B on its own account. It is moving. It has possessed some energy, and because of that, it is moving. So this energy has been imparted because of the velocity. It is having some velocity, right? So it is having some kinetic energy, and because of this kinetic energy, this particle is moving ahead. So mass of B into acceleration of B. So it's going to be how much? Mass of B is 3, so that's 3 times of acceleration of B. So can I say by D'Alembert's principle, I'm again going to consider only summation of Fx. No need to consider summation of Fy. So that's principle. So I can write summation of Fx equal to 0. So what do I get? Summation of Fx equal to 0. I get 3 times of acceleration of B is equal to, not is equal to, plus, right? Both of them are going down. So I'm taking down as the positive direction. Okay, down is taken as positive direction. There is no other third force except these two forces. So plus 30 cos of 72 degrees equal to 0. So from here, the acceleration of B is negative. Did you see acceleration of B is negative? It means what? The velocity is definitely going to decrease. So acceleration of B is going to be 30 cos of 72, right, divided by 3. So it's 3.09. Acceleration of B has come minus of 3.09. Let's confirm it one more time. So that's 30 into cos of 72. I've got some value, and this value gets divided by 3. So it's 3.09, 3.09017. So that's acceleration of B, right? Now you can easily make use of V square is equal to U square plus 2as. So V, the final velocity is 0. Initial velocity U square, it is 1.9314 V square. This value, students, 1.9314 V square, 1.9314. You know it, right? Now for the second journey after the breaking of A has happened, okay, this part will have what initial velocity? It's the final velocity of the first journey, right? So 1.9314 plus 2 times of acceleration I've got is minus 3.09017. So I'll write here plus 2 times of acceleration is minus 3.09017 times s. Okay, I'm interested in the value of s. So see, s will come positive. So it's 1.9314, which was v square, or here it is u square, divided by 2 times of 3.09017. I get the answer as 0.3125. S is 0.3125 meters, right? That means after A has separated from the system, B will again keep on traveling for some distance, and that distance is 0.3125 meters. So the total distance traveled by B, therefore I can say now, so there is some more space available which I'll be using to explain you the second method. Okay, so therefore I can say total distance traveled by B is going to be the initial one, 0.45 meters plus 0.3125 meters. That comes out to be how much? So I just add plus 0.45. It will come 0.7625 meters. 0.7625 meters. So after the decimal, you want to keep 3 significant figures, right? So it's 0.763. 0.763 meters. So that's the answer by using what? By using the D'Alembert's principle. So students, it's very tricky, right? These concepts are very tricky. The question has come for 8 marks. You need to know the entire concept very thoroughly. So that was the solution of the question by using what? The D'Alembert's principle. I'm going to now continue further, and I'm going to solve the same question by using the work energy principle also. So students, let's proceed ahead with the work energy principle. Students, you might feel that why there is any need to solve the same question by a different method. Once we have understood one of the method, then there is no point in studying the other method. But believe me, if you solve this question by the second method, the work energy principle, you're going to find that the second method can be slightly more easier than the first method, and that is what we are going to see, and that's the reason why we're going to start with the second method also. So knowing both the methods will always get you in a very better position. Okay, now of course only practice will bring that decision making power into you, which method needs to be started in the exam. Now since it's an 8-mark question, you need to give justice to this question. Okay, of course we will not be solving this question by both the methods in the exam. We will be attempting the question by only one of the method, but then you need to know which method we need to start with. So I am going to give you As I said, both the methods. You can then later on decide on your own which method you find more comfortable. So the second method, if you now see for this question, will be slightly easier than the first method. So it's just a matter of another 10-15 minutes to understand this question. I would strongly recommend, advise you that you continue watching this entire solution up to the end. So students, let's begin with the work energy principle for the same question. So again, when you are doing work energy principle, there is no need to separate the bodies. Now students, why did I pick D'Alembert's principle at the beginning? I'll give you the reason for that, why I picked D'Alembert's principle, and then I'm taking the work energy principle. So whenever there are bodies which are connected to each other, whenever there are strings and they're attached to the bodies, so usually D'Alembert's principle makes more sense to be applied. That's why I went ahead with the D'Alembert's principle at the beginning. Okay, but then the work energy principle can also be applied to all the questions where D'Alembert's principle is applied. So you can apply any of the two methods. So sometimes D'Alembert principle is more easier compared to the work energy principle. Sometimes work energy principle becomes more easier than the D'Alembert principle. So you need to know both the methods. So what I'm going to do here is I'm going to draw the entire diagram one more time. I'm not going to separate the bodies now. So in work energy principle, you need not separate the bodies, but in D'Alembert's principle, you had to separate the bodies. Okay, you have to consider FBDs of both the bodies individually. But in work energy principle, I'm not going to separate the bodies. So I had an inclined plane, which was inclined by an angle of 18 degrees. Then we had a pulley over here, right? We had a pulley, and there was a string passing over this pulley. So to one of the string, A was connected. So let's make block A. Let's make block A very quickly. Let's block A. Okay, the mass of block A, if you recall, was 2 kg. Mass of A, it was 2 kg, right? Then let's draw a string, of course not this much big. We'll shorten it, and then we'll attach block B over here. So that's block B. The weight of block B, if you remember. So first I'll write the mass of block B. It was 3 kg, right? And the inclination was it 18 degrees? Let's quickly confirm. Yeah, it was, yeah, 18 degrees. Okay, so this is what a diagram is given to us, and the distance of A from the ground was 0.45 meters. So that's the ground. So this distance is given to us 0.45 meters. This is 0.45 meters. You got that? So as you know, the work energy principle says what? So the total work done on the system should become equal to the change in the kinetic energy, right? The total work done on the system. So the work done can be due to an external force. In the system, there is no external force. The work done can be because of friction. There is no friction here. Work done can be because of springs. There is no spring here. Work done can be work done can be there because of the gravity. So there is gravity here, right? So B and A, both of them are under gravity. So they are both moving under gravity. So before string A breaks, again the question, the solution will be separated into two different parts. The first part where string A and B both move, particle A and B both move when the string is attached, and when block A gets separated, the string breaks from block B, and block B continues its own journey without block A. So that will be the second part of the solution. So in the first part, let's make use of the work energy principle. So by work energy principle, total work done by the system is equal to change in kinetic energy of the entire system. Okay, now the system consisting of both body A and B. So this is when block A is still attached to block B. Okay, block A and B are attached. A and B are attached. Okay, so now what I'm going to do here is the total work done by the system is only due to gravity. So block A is going down, it is in the direction of gravity. So work done on block A is positive. Work done on block A, it will be positive, right? And then block B is going against the gravity, it is going up, right? So block B is traveling up the plane. So if block B is traveling up the plane, it is traveling against the gravity. And by how much distance it has traveled? So since block A has moved by 0.45 meters, block B will also move by 0.45 meters, right? So block B is going to move by 0.45 meters. So I'll just draw block B here one more time. That's B, and the distance traveled, so from here to here, or I'll draw the entire one. This distance is how much? This is 0.45 meters. But is it the vertical displacement of B? The answer is no, students. You might be recalling one question that we have solved in this session, right? This is not the vertical displacement. This is the displacement along the plane. I need to get the vertical displacement. So what I do is I draw a right angle triangle like this. Isn't it? I'm going to draw a right angle triangle, students. Okay, this is a right angle triangle. If I name it, let's say this point is P, this is Q, this is R. This is a right angle triangle, and the length of PR is 0.45 meters. This angle is 18 degrees. So this is the vertical displacement of B, right? Vertical displacement of B. So I'm going to get the length of QR. So QR is going to be equal to what? So I know sine of 18 degrees. So I'll write like this first. Sine of 18 degrees is equal to QR upon PR. So PR is how much? PR is 0.45. So QR would be 0.45 into sine of 18 degrees. Is that right? So very quickly we'll get the answer. Students, 0.45 into sine of 18 degrees. So let's get this answer by using the calculator. So I have 0.45 multiplied with sine of 18. So it came 0.139. Okay, so the length of QR is 0.139057. So 13906 meters is what I have taken the length of QR, which is the vertical displacement of B. So work done on block A, which is positive, plus the work done on block B, plus the work done on block B. And since it is going up, so this work done is going to be negative. So this concept should be very well known, students, otherwise there will be a mistake. Okay, and is equal to change in the kinetic energy of the system. So 1 upon 2, so kinetic energy is what, half mv square. So 1 upon 2 final kinetic energy minus initial kinetic energy, so half mva square plus half mvb square. That's the final kinetic energy. V and vb are the final velocities, right? Minus half m ua square plus half m ub square. Now tell me, what are the initial velocities of a and b? So ua and ub, both of them are going to be equal to 0. Initial velocity of the system is 0. The system is not in motion, right? So ua and ub, both of them are equal to 0. According to string law, you remember this, n of a into va is equal to n of b into vb, isn't it? The string law is remembered by you. So na into va is equal to nb into vb. There is one string attached to block a, one string attached to block b, so va must be equal to vb. Final velocities must be equal. So I can write here va is equal to vb, and let's say it is equal to v meter per second. So work done on block a due to gravity, okay, work done on block a and work done on block b, this is due to gravity. So I know it is given by mgh. When the block moves in the direction of the gravity, the work done is positive. If it moves away from the gravity, it is negative. So I can write here mass of a mg, height of a, right, plus mass of b, g, height of b, must be equal to. So of course, this second term that you have, this second term, this is entirely 0, right? So it's not going to come. This term is not going to be written over there. It's 0, so it's vanished. Then half of mass of a, I forgot to write mass of a and mass of b here. So 1 upon 2 mass of a, va square, that's just v square, right? Because v and v, both of them are equal. So I'm going to write here 1 upon 2 mass of a into v square plus 1 upon 2 mass of b into again v square. So what do I get now? Mass of a is how much? It was 2 kg. 2 into g is taken as 10 and height of a is 0.45, right? Plus mass of b. Mass of b is, so plus is there, okay? Mass of b is how much? So mass of b is 3 into 10, but the height is negative. Why height is negative? Because it is acting in the opposite direction. So height, I will take how much? Height, I will be taking minus of 0.13906. So minus of 0.13906. Okay. So that's the left hand side, work done on the system. This is equal to half of mass of A. Mass of A is how much? It was 2. So 1 upon 2 into 2 V square plus 1 upon 2 into 3 into again V square. So from here, I'm going to get the value of V square. So that's 2 into 10 into 0.45, 2 into 10 into 0.45 minus 3 into 10 into 0.13906. That is some value 4.8282. Okay, this is 4.8282. That is equal to. So the 2 and 2 will get cancelled here. You got V square plus 3 upon 2 V square. That will give you 5 upon 2 V square, which is 2.5 V square. So what will be the value of V square? So it's 4.8282 divided by 2.5. That comes out to be 1.93128. That's the value of V. If you take square root of this answer, you get the value of, that was V square. You get the value of V, 1.3897. 1 meter per second. So you can recall this was the same answer that you have got for V square, 1.9314, 1.93128, very close, right? 1.9313. So it's a Very close answer if you observe. So I've got the value of v square, I've got the value of v. Now what will happen? System will break. Now there is no block A, only block B is there. So again, if I draw just the FBD of block B, let's draw the FBD of block B. So now this block B will still continue its journey for some time, isn't it? I do not know for how much time and how far it is going to go. This is block B. So it will travel, let's say, to this distance. Okay. This is where block B has reached. This is the second part of the journey when block A has separated from block B. So until now, block B has covered a distance of 0.45 meters. So this distance, if you recall, this is 0.45 meters. I want to get what is the next distance. So I'll draw vertical lines like this. I do not know what is this distance. This is what I'm trying to find. I will call this distance as, say, x meters. Okay. I'm going to call this point as P, this point as Q. Let's complete a triangle because we are going to make use of work energy principle. Okay. So I will need the vertical displacement of the particle, right? I will need the vertical displacement of the particle. This point is R, let's say. So I know length of PQ. I know that this angle is 18 degrees. So this is QR. This is the vertical displacement, right, students? This is the vertical displacement of the particle. So vertical displacement, I can use sine of 18 degrees is equal to what? It is equal to the opposite, which is QR, upon the hypotenuse, which is X. So from here, QR is equal to X into sine of 18 degrees, right? Right. Now, again, we make use of the work energy principle. So by work energy principle. So work done by gravity on block B. So mass of B, right, into gravity into height traveled by B. There is no A, and this is going to be negative. Why this is going to be negative? Because the particle is going up. It is going in the opposite direction of gravity. This is equal to change in the kinetic energy. So now the particle B is going to come to rest at this place, right? So the velocity of B is going to be 0 meter per second. And here the velocity of B, let's call it as UB. It was what? It is the place where the first journey has ended. And here what was the velocity? 1.38971 meter per second, right? So final kinetic energy is half m VB square minus half m UB square. But UB is there, VB is 0. So mass of B, that's 3, G is 10, height of B is x times of sine of 18 degrees. 1/2. Mass of B is 3, VB is 0 square, right? Minus 1/2. 3 into U square. So U square was 1.93128. 1.93128. So finally, I'm going to simplify the students. X is given by what? So I have 1.93128 multiplied with 3 divided by 2. That's the right hand side. This gets divided by what? This gets divided by 3 times 10 times sine of 18. Right? That comes out to be 0.312487. So X is definitely 0.3125 meters. And now you know that the total distance traveled will be 0.45 plus 0.3125. So therefore, the total distance is going to be equal to 0.45 plus 0.3125, and that is definitely the same answer which we got from the previous method also, right students? It was 0.7625. Was it the same answer? 0.7625, right? 0.7625, or I can say 0.763 if I take three significant figures. So students, we have completed the entire question paper of mechanics, and I'm pretty confident that this entire thing is well understood by you. I'll go ahead and quickly stop sharing my screen. So students, in this entire session we have learned lot many concepts about different topics. Okay, now the only thing that you need to do is go through all the questions very properly, revise them, try and solve on your own. Okay, and if you're not getting them, you can come back and revisit this entire video. So that's all from my side, students. I'm pretty confident that the entire thing was properly understood. You have enjoyed the entire session. uh, if this video, students, has brought any change in your life, if it has added value, if it has increased your knowledge, then please go ahead and hit that like button. Do share this video with your friends, and make sure, students, that you subscribe to the channel, because subscriptions gives me motivation to create more such videos. So students, that's all from my side this time. Until we meet next time again for with a brand new paper, you all have a great day ahead. Thank you for watching.